Chalo, everybody, all of you guys are ready? Shall we start? Today is our last session of circular motion. Okay, and this is one of my favorite part of circular motion that we are going to study today. Quickly. Say +1 in the chat box if you guys are ready for the session. Okay, thank you. So everyone knows that now I'll be switching off the chat. You know that you can ask your doubts with the class teachers as well. If you have some specific kind of doubts that you want to ask me, please keep them noted down. At the end of the class, you can ask me all those doubts, right, everyone? Okay. Oof. Okay, guys. Sure. Yes. Okay, chalo everyone, switch off the chat so that we all focus upon the session. अगर तुम्हें मुझसे other than academics की बातें करनी है, if you want to speak to me after the class, stay back. Okay, so everyone, quick recap. Last time we spoke only about two specific cases, and those were how a vehicle will take a circular turn when it is on a road, level road, or on a hill station road. So we spoke about a flat surface, and on flat surface it is force of friction which behaves as centripetal force, and that is why mu mg, the friction force, should be always greater than or equal to minimum it should be equal to mv square by r. Okay, so the safe speed is under root mu rc. That's the maximum speed with which you can take a turn on a circular track when your vehicle is going on it with the help of the friction. Okay, but if you do not want to rely completely on friction, then you will have to bank your roads so that it's not force of friction which will provide you the centripetal force, it will be the normal force which will provide the centripetal force. So in that case, the banking angle is calculated as v square by rg. This is also the same case when you want a cyclist. Okay, so bending of a cyclist is also based upon the same thing. Bending of a cyclist, we spoke about this. So when the motorcyclists, when they don't want to compromise on the speed with which they are moving, especially during a race, so they actually bend towards the center of the circle, and they, without compensating on their or compromising on their velocity, they're able to take the turn. So the maximum speed with which they are going, if that is v, then the angle by which they can actually bend is v square by rg. Okay, guys. So based upon the same, let's quickly solve the question. Quiz for all of you guys. A cyclist is riding the bicycle with a speed that is 14 root 3 meters per second. He takes a turn around a circular road of radius 20 root 3 meters without skidding. Given g is equal to 9.8 meters per second square, what do you think is the inclination to the vertical? With the vertical, the angle has been asked. Okay, guys. So make sure that you guys are finding this angle with the vertical. Okay, so your angle of the cyclist, if cyclist is bending like this, if this is the cyclist, this is its tire. So this angle has been asked. Okay, people, and this angle is what we just now saw, v square by rg. Giving you all 90 seconds. Take your time, and your time starts in 3, 2, and 1. I'm super excited for today's topic, so quickly we want to reach there. That's only one question in quiz today. Okay, everyone. $60 seconds remaining. Last 20 seconds remaining. Come on, everyone. Last 5 seconds. Okay, time's up. Let's see. Okay, so formula was already there. It was only about the calculations. So you were supposed to do those calculations correctly. Okay, guys. So v square by rg, v is 14 root 3. If you will square that value, 196 will come, and 196 is divisible by 9.8. That is something that you should know, right? So I guess it is divisible. I'm not sure. I said it with so much of confidence. Is it directly divisible? Yes, it is. It's just double of 98. Okay, so only that root 3 will be left. 14 ka square is 196. 196 is divisible by 9.8. 20 times 20 cancels, and you have 3 by root 3. So I could not have actually given you 90 seconds, but some people might have found it a little challenging calculations wise. Some people might have used a calculator also. I don't know that. Okay, so anyway, formula is important as far as the concept is concerned. We have already seen that previously. Now we'll move to something which I can say is one of the most important parts of this chapter: vertical circular motion. So far I told you people, whatever circular motion that you studied, we assume that it was happening in this horizontal plane, or it was happening parallel to the ground. Why we were talking about circular motion where circle was horizontal? Because we did not want mg to play any role in the motion of the body. So this is basically where the center was. This is the velocity of the body so far. This used to be the situation, and this was centripetal force. So basically, your most important force, centripetal force, has nothing to do or had nothing to do with the gravity. So every point where the body was moving, gravity was acting perpendicular to the plane of the circle, or perpendicular to the velocity. Hence, there was no practical impact of gravity on the velocity of the body. And now, when we will speak about the vertical circular motion, now we want to actually look at the implications, the effect of gravity on a body which we want to move in a vertical circle. That means take a stone, connect it with a thread, and you want to make it move like this. This is the vertical circle. The best example would be any merry-go-round, SL World, or any what do you call this, amusement parks. You might have gone there in fairs in general. You will find those merry-go-rounds. They are basically the vertical circular motion that we want to discuss here. Okay, guys. So there are two specific cases that we study in vertical circular motion. I'll take you to there after some time. Let's first see what happens during vertical circular motion. Definitely, the gravity during this entire motion of the body will continuously be acting vertically downward. Wherever the body is, the gravity is continuously acting downward, right? Hope you guys are able to see that. This is basically your vertical circular motion. That simply means what? Not every time the gravity is acting towards the center or away from the center. There are only 2 points, A and C, where you can see that mg, the weight of the body, is trying to act along the radial direction. Right, everyone? You're able to see that? This is your vertical line, and along this vertical line there are only 2 positions during the vertical circle where gravity comes on that line and is also the radial direction. Okay, at C it is acting radially inward, at A it is acting radially outward. That means what? This is where your center O is. At C the gravity is trying to act towards O, and at A the gravity is trying to act away from the O. Right? It is actually acting the same way everywhere. It is only the path of the body where the beauty is that point A and C are the only positions where gravity is radial in direction. Okay, guys. So definitely there will be more force which will be acting on the body in order to make it move. Like if we speak about a stone which is connected to a thread, or a bob which is connected to a thread, then the case number 1, as you all see here, is when the particle is oscillating in the lower half circle. That means particle is going like this. That means what? It is part of vertical circle. Body is not able to complete the circle. That's what it is. That means the body, one very important point I forgot to mention is that definitely when the body is going to move, if you take a body and you give it a velocity here, and after that you do not do anything, you do not apply any external energy, you do not provide any external energy, you have given that energy in the form of kinetic energy to the body. With that kinetic energy, as the body will progress upward, its kinetic energy is going to decrease and its potential energy is going to increase. That simply means what, guys? There is a value of velocity for which the body may not be even go to half of the circle. It may remain only in the lower segment, as you see it in the diagram, right? For this, maybe the kinetic energy is not sufficient enough to even take it to the half position here, right? This is the half position. Then maybe the case number 2, where you are able to take the body above the half position as in half the circle is crossed, but body is still not able to complete the circle. That means what? Here you have given some velocity to the body. The initial velocity of the body has been given, which is non-zero, but after the body has reached this position, say P, the body's final velocity becomes 0. So from here, the body will simply fall. It will again gain that the strength in the string, and then the body will start to oscillate. Whatever will happen. What is important is that body will not be able to go beyond point P if sufficient kinetic energy is not given. This particle moves to the upper circle, but is not able to complete the circle. It is still unsuccessful in completing the one circular part. It has only gone like this. Okay, I will try to show this by a proper circle. Okay, yeah. So this is basically what we are expecting or what we wanted to happen, but does not happen. This is where the circular part is not completed. Only A to P happens, and then body stops and comes back. It may not come back with the same path. It will just fall vertically downward and then starts to oscillate. Whatever will happen. And then the third possibility, which is what our area of interest lies in, the particle completes the loop. It is able to complete this vertical circle. Right, everyone? I hope you guys are able to visualize this, that body being able to complete the vertical circular motion or being able to complete the vertical circle, it actually depends upon how much kinetic energy is given to the body at the bottommost point. If you do not provide sufficient amount of kinetic energy for the body to complete the vertical circle, the body will not be able to complete the circle. Hence, case 1 and case 2 will happen. And that is why case 3 will have a particular type of situation. This is case 1. Okay, everyone? This is case 1, when you have given the velocity but the body is not able to complete the circle here as well. It's just oscillating. Right, everyone? This is the part of the circle which we wanted the body to complete, but the body is not able to complete that circle also. Only the solid part of the graph, not the graph, but the path is where your body is able to move. The body goes, and if this position is O, the velocity at O is not equal to 0, but velocity, if this position is A and this position is B, velocity at A will be 0, velocity of body at B will also be 0. I hope you guys are able to understand this part. Okay, guys, do you realize that in case number 1 and case number 2, whatever kinetic energy you gave to the body, it converted into potential energy, and finally at point P here, the potential energy is the only energy, kinetic becomes 0. Right, everyone? Its entire kinetic energy converted to potential energy, and the body stopped, and then whatever will happen will happen. This also is the case where some of the kinetic energy converts into potential, but the body does not stop. The body continued to move. So there is this minimum kinetic energy that I need to provide to the body so that the body not only goes to the topmost point, it also completes the circle. Can I say the most difficult point for the body to reach is? I will not say it. You will say it. The most difficult point for the body to reach is topmost point. अगर एक बार body topmost point पे पहुंच गई successfully और उसके बाद कुछ भी velocity बच गई, if it has some velocity left at the topmost point, the body will be able to convert the circle completely. Okay, got it, everyone? Perfect, awesome. So धीरे-धीरे समझेंगे बहुत सारी चीजें हैं. We will see everything. Okay, guys. So first, I will tell you about the generic dynamics of the circular motion. First, we'll speak about the force during the vertical circular motion. So this is the situation which you are studying, where I am considering a stone tied to a thread. Okay, that means what? There is no question of normal force. There is only what force will come into existence in the chat box. Tell me the types of forces which will be acting on the body when it moves. Definitely mg definitely. What are the force the body will experience? Force of tension. Okay, जितने लोगों ने centripetal force बोला ना, उन सबको virtual थप्पड़ पड़ेगा. Centripetal force is not a fundamental force. Centripetal force is not a fundamental force. A force will behave as centripetal force. Okay, tension and mg. वंश ठाकुर, तुम एक और बार न्यूज़ लिखो चैट बॉक्स पे, मैं तुम्हें ब्लॉक करता हूं अभी के अभी. ओके, सबके घर में टीवी है, सबके घर में न्यूज़पेपर आते हैं और सबके घर में मोबाइल फोन्स भी हैं. तुम अकेले न्यूज़ रीडर नहीं हो. सर हमको लगा आपको पता नहीं हुआ. क्यों? मैं क्या मास्क पे रहता हूं जहां इंटरनेट नहीं है? क्या मेरे घर में मोदी जी ने इंटरनेट बंद करवा के रखा है? टीवी घर से लेके चले गए मेरे? हाँ, या मुझे डॉक्टर ने मना किया न्यूज़ मत देखो? चलो शांत, stop the chat. मेरा favorite topic है यार. This is my favorite topic. I don't want somebody to ruin it. Okay? Thank you for stopping the chat. Okay, cool, everyone. So there are two forces which are acting on the body. There might be other situations where the vertical circular motion will happen. So whatever be the force which is acting on the body, those forces have to be identified. That means what? Long time ago we studied a chapter called as Newton's laws of motion. We learned how to draw free body diagrams there. We learned it once, but we keep on applying it everywhere, as I told you. That's one of the things that we will be doing here also. We'll try to now, henceforth, as I told you guys, after laws of motion and work by energy, almost in every chapter you will be applying the two set of laws that you have learned so far. First set of laws are laws of motion. You will be checking whether the body is at rest, the body is moving. If the body is at rest, the net force acting on the body is zero. If the body is accelerating, the net force acting on the body is equal to mass into acceleration. That is coming from Newton's laws of motion. The second law you learned in the previous chapter, work by energy, law of conservation of energy, especially mechanical energy, and that's what is going to happen here also. That means what? We are assuming everything is happening in vacuum. No air resistance, no friction, no viscous force. The mechanical energy of the system will remain constant. Why? Because there are only two forces acting on the body, mg and tension. Both are conservative forces. Conservative forces do not increase or decrease the overall mechanical energy of the system. Quick recap of the previous two chapters. Now everybody, look at this diagram. You will find an instantaneous position of the body when the body is moving in the vertical path. So there are multiple positions possible, by the way. The body will definitely be at different locations at different point of time. So we have taken a picture of the photo and the body is picture of the body when it is moving in the vertical circle. Say its radius is r and the body is right now located at point P. So body is at point P. Okay, it is moving in the vertical circle successfully. And at point P there are two forces which are acting on the body. The force number 1 is tension. The force number 2 is definitely mg. These are the two forces that you guys also identified. And now the important part. You know that in circular motion, we try to talk about forces into two types. We try to talk about forces along two directions. One of the direction is radial direction. The other direction is tangential direction. So basically, let me just take it back a step before. So say if you are dealing with a circle, okay, if you're dealing with a circle or a body which is moving in the circular path, and maybe your body is here at this position which you see here, right guys? So one direction that you are going to deal with is tangential direction, which is this. and the other direction is the radial direction, which is this, when the body is at position P. Now, if your body is at position Q, random points which I'm considering, this is the tangential direction, everyone, right? May not be the perfectly drawn tangential direction, but yes, you guys are getting the point. The other direction is the radial direction where the forces might be acting. Randomly chosen a very generic point. This point was Q. Say this point is S. So when the body is at S, the tangential direction is this, and the radial direction is this, right, everyone? So point is, my dear friends, whatever be the forces which are acting on the body, my objective is actually to bring all the forces along this direction and along this direction. Maybe the body is going in the clockwise sense. So we'll say that this is centripetal force, this is tangential force. We'll say that this is centripetal force, and we'll say that this is tangential force. Tangential force may not be present, but because vertical circular motion sees continuous change in its kinetic energy. Continuous change in kinetic energy means body, when it keeps on moving up, its kinetic energy decreases, potential increases. When the body starts to come down, its kinetic energy increases, potential decreases. That means there's continuous increment or decrement of speed happening. And whenever speed changes, tangential acceleration happens. Speed change, tangential acceleration, that means tangential force will always be there. In short, vertical circular motion is a very beautiful example of non-uniformly accelerated circular motion. Again repeating, ध्यान से सुनना. During vertical circular motion, you understand this by your instinct, by your own common sense, that when the body will go up, its kinetic energy and its speed will decrease. When the body will come down, its kinetic energy and speed will increase. That means there is continuously change in the speed happening. And we know that the tangential acceleration is change in speed upon change in time, rate of change of speed. Right, guys? If this is there multiplied with mass, you are basically talking about tangential force acting on the body all the time. Hence, if there is force which is acting on the body and continuously the body's speed is changing, so it is non-uniformly accelerated motion. Every time when the body is moving, definitely an accelerated motion, non-uniform circular motion it is. Okay, guys? अब तक जो भी बोला समझ में आ रहा है? +1 in the chat box. So whatever be the forces acting on the body, my objective is to bring all the forces acting on the body along tangential and radial direction. I will make sure that either my forces are along this radial line or the forces which are acting on the body are along tangential direction. Okay? You will see this very beautiful and very challenging at times. So you will have to pay attention, complete attention when I'm explaining this part. Okay, guys? Chalo, thank you. So guys, coming back to the diagram, you see this in this diagram right now. You see that there are two forces acting on the body. Okay? Any force already acting on the radial direction by looking at the diagram, everyone, position is P. Any force already acting on the radial direction, tension you see already pointing towards the center. That is radial direction. That means it is connecting. It is on the line. It is connecting the circle center with the circumference. Right, guys? Okay. But do you see that mg is neither tangential nor radial? mg is neither tangential nor radial. mg जो है वो ना तो radial direction में ना tangential direction में. Right, everyone? So मैं क्या करूँगा? Exactly. I will resolve the mg force. Get the logic why mg is being resolved, everyone? Getting the logic that why mg is being resolved because mg जो है वो नहीं है radial or tangential direction. So I'm resolving it. Resolution is something that you all are expert now. You see that mg cos theta and mg sin theta are acting on the body. mg cos theta is acting along radial direction, but that is radially outward direction. mg cos theta is acting in radial direction, but that is radially outward direction. Means what? It does not want it will actually try to decrease the centripetal force because centripetal force direction is always towards the center. Centripetal force always acts towards the center. It is actually acting away from, but it is not centrifugal. Centrifugal मत समझने लग जाना अभी. Centrifugal नहीं है. This is everything being seen from outside. There is no centrifugal force considered yet. Okay, guys, you see that right now the radius, or you can say the string, is making the angle theta. Are you guys getting it so far? Okay. So people, if I want my entire force to be acting towards the center, we know that the net radial force should be equal to mass into centripetal acceleration. Can I say this should be true for radial forces? The net radial force should be equal to mv square by r. Can you people tell me what is the net radial force by looking at the diagram here? Net radial force, बता सकते हैं? Exactly. Love you guys. Awesome. T minus mg cos theta. Why T minus mg cos theta? Because effectively the radial force should be towards the center. That means T has to be greater than mg cos theta. Remember this point. Remember this point. This is a very important point. T has to be greater than mg cos theta. And practically it will be. It will be. Okay? So T minus mg cos theta is equal to mv square by r. What is the job of mg sin theta then? What is the job of mg sin theta then? Exactly. This will be MAT. Getting it? So what is tangential force acting here? It is mg sin theta, which is equal to MAT. क्या बात है? Sir, if T is less than mg cos theta, हाँ, बहुत अच्छा point बोल दिया वैसे तो किसी ने. अगर ये condition satisfy नहीं हुई, if mg cos theta is more than tension, spring will break. Spring will break. That's what will happen. Happens also. Accidents happen. If you have a stone, if you start moving it very fast, it may break. Spring may break. Okay. Sir, what if they are equal? If they are equal, the body will not be able to move in the circular path. Then the centripetal force becomes zero. Okay. Okay. Switching off the chat, everyone. Yes, Captain. हाँ, Captain. Doubt पूछो जल्दी. अरे तुम सवाल पूछो सीधा. How T can be less? T is never less than mg cos theta. T has to be greater than mg cos theta. ये रेडियल डायरेक्शन समझ में आ रहा है? OP जो डायरेक्शन है वो रेडियल है. हमेशा O और P के बीच में जो फोर्स लगा होगा वो O की तरफ आना चाहिए. उसका इफेक्टिव डायरेक्शन वैल्यू, उसका जो नेट न्यूमेरिकल वैल्यू है वो O की तरफ आना चाहिए. तो T should be greater than mg cos theta. और यही मैंने यहाँ लिखा हुआ है. अगर mg cos theta बड़ा हुआ by any chance तो स्प्रिंग ब्रेक हो जाएगी. ठीक है? मैं गया नहीं हूँ अभी तक एक बार भी, तो I'm not able to relate, but I can understand. Okay? Cool. Okay, Arshad. चलो guys, so enough field taken. अब आगे बढ़ते हैं. You guys have seen one aspect of the situation. I told you one situation comes from laws of motion, the other comes from work power energy. And everybody, during this entire motion, any point you consider A, B, C, D, or P, A, B, C, D, or P, you consider any two points where the body is. You can say that the mechanical energy of the body between any two points will remain same. Nothing will change. Mechanical energy means kinetic plus potential energy. का value will remain same. You compare any two points on the body. That's why when you compare position A and position P, P is a very random position. At P, you see that the body is at a location where the radius of the body is making an angle of theta with the vertical, the one which we were seeing on the previous diagram. So we can say that at A, first of all, we define point A reference level to be 0. That means height of point A is taken to be 0. Height of A is taken to be 0. If you don't want to take it, that's fine. But usually in vertical circular motion, point A will be taken as the point where height of the location is 0. You know that potential energy will require h equal to 0 defining. That's why we have defined that. So at A, there is no potential energy because you have said that the height is 0 there. Okay. So whatever is the velocity of the body, that is u, it will have half mu square, the kinetic energy over there. Potential energy became 0. I will make that value 0. So 0 plus half mu square means 0 potential energy, half mu square kinetic energy at A. Come to point P. The body has v velocity now. definitely body velocity will decrease. Definitely will decrease magnitude wise. So at P, now the body has gained some height. You see that h height has been gained by the body. This h, the body was here, and now the body has reached here. And at h, the potential energy becomes mgh, kinetic energy becomes half mv square. M gets cancelled. You rearrange everything. You get the value of velocity at point P to be written as u square minus 2gh and root. Law of conservation of energy. Simply nothing else. Law of conservation of energy. It is. Now I'll tell you. I'll show you how to correlate h with the radius of the circle. That means this height will be variable as theta will change as the body will go up. This theta value. If the body is at A, theta value is 0 degree. If the body is at B, tell me in the chat box what is the value of theta. At B for Bombay, the value of theta is 90 degree. At C, the value of theta is at C 180 degree. Perfect. At D 270 degree. At A again, don't say 360. 0 is also fine once again. Okay, everyone. So we are generalizing it. So pay attention once again. Thank you, everybody. So you see that this point is O, this point is A. So this total height or total distance between O and A. Total distance between O and A is nothing but the radius. Total distance between O and P is also radius. That's the beauty of a circle. All the points on the circumference are at the same distance from the center, right? So OP is also R, OA is also R. And let's talk about this छोटू triangle. Let's call this point B. नहीं B नहीं बोल सकते. P dash or Q बोल रहे हैं. Let's call this point Q. So OPQ is a right angle triangle, and say this length is Y. This length is Y. Okay, guys. In this right angle triangle, if you will write down, what will you write down? You'll write down cos theta. You'll write down cos theta. Can you people tell me cos theta expression in this right angle triangle OPQ in terms of Y R? जल्दी देखिए बताओ, everyone. You see that the adjacent side is Y and hypotenuse is R, right, everyone? So Y I can write as R cos theta. किसी को कोई तकलीफ नहीं, right, everyone? Y is equal to R cos theta. Very good, very good. And look at OA. Look at OA. Can I say OA is basically Y plus H? Yes, everyone. Y plus H. And what is OA? Is it equal to R in itself? OA खुद अपने आप में R value है, तो H क्या हो गया? R minus Y, right, everyone? That means R minus R cos theta. Getting it? Are you all getting it or not? Getting it right? Y का value R cos theta put कर दिया. H comes out to be R 1 minus cos theta. अब तुम थीटा का वैल्यू अलग-अलग वैल्यू जो अभी हम लोग बात कर रहे थे ना, थीटा वैल्यू at A is 0 degree, at B is 90 degree, at C is 180 degree, पुट करके देख लो, तुम्हें वही हाइट मिलेगी जो है. At A if you put theta is 0 degree, cos 0 will be 1, bracket will be 0, height will be 0, and that is what it is. At B theta is 90, put 90 degree, तो कितना हाइट हो गया? Body is at B. B का height with respect to A is how much? It's equal to radius. Okay. At C, put 180 degree, 1 and cos 180 is minus 1, so 1 plus 1 will become 2, height will become 2h, sorry 2r. Feel आ गई? Okay, sir, but OQ is also R minus H. हाँ, उसी को Y define किया है मैंने. R minus H को ही Y define किया बच्चा. Okay, R minus H is Y. Cool. तो तुमने अभी तुम्हारे पिछले दोनों चैप्टर्स का एप्लीकेशन देखा है. पिछले दोनों चैप्टर्स जो तुमने सीखे हैं उसका एप्लीकेशन है. लॉज ऑफ मोशन यहाँ पे अप्लाई हुआ अभी और वर्क पर एनर्जी का मैंने जो बोला था, लॉ ऑफ कंजर्वेशन ऑफ एनर्जी मैथमेटिकली बहुत बार अप्लाई करेंगे हम थ्रू आउट 2 इयर्स, बहुत बार अप्लाई करेंगे. ग्रेविटेशन में तो हर बार अप्लाई करेंगे, यू विल सी दैट. ओके, सो एवरीबॉडी दोनों इक्वेशन देख चुके हैं और तुमने मुझे आधा काम यहाँ पे पहले कर दिया था, तो इस इक्वेशन को दोबारा से देख लो. ये लिखा हुआ T minus mg cos theta equal to mv square by r. ओके, कूल. ओके, गुड. तो टेंशन का वैल्यू एट एनी पॉइंट कम्स आउट टू बी mg cos theta plus mv square by r. क्या मुझे याद रखना है? बिल्कुल नहीं, कभी नहीं याद रखना ही नहीं, समझना है. यू हैव टू जस्ट अंडरस्टैंड दैट इन वर्टिकल सर्कुलर मोशन एट एनी पॉइंट ऑफ टाइम यू हैव टू अप्लाई two things. One, second law of motion. Net force acting on the body will be equal to mv square by r in central direction, radial direction, and tangential direction. The force will be equal to mass into tangential acceleration, as you saw it here. This is learning. This is not maths written here. This is concept written in front of you. This is concept number 1 with respect to forces. This is concept number 2. Okay, both forces will be non-zero. They will act during vertical circular motion. So this is concept number 1. Concept number 2, law of conservation of energy. Clear? अब आते हैं ऑब्जेक्टिव के ऊपर. Okay, everyone, we have already spent like 38 minutes. Nothing learned more than that. So this is our objective for today, guys. Small objective, very important. We have to find out, as you remember, whatever velocity you give to the body at the bottommost point, there is a minimum value of velocity and kinetic energy required by the body to reach to the topmost point. So we want the body to reach to point C. But what is the objective? I want the body's velocity at point A, at point B, and at point C. And also I want the value of tension acting on the string at point A, B, and C. You will realize that point B and point D are identical in terms of velocity and in terms of tension because of their location. They are identical, B and D. When will I be finding these point number 1 and 2? The situations. Situation number 1, try to understand it, very important. Situation number 1 says, when the body just completes the vertical circle by crossing point C. That means when body reaches point C, it just crosses that point C. Just crosses. That means what? It is the minimum velocity that you require at point A with which you should shoot the body up. That the body is not only just able to reach C, it is also able to cross it. That means what? At C, the body must experience some velocity which takes the body just crossing the point C. Okay? I'll speak about that condition in some time. Point number 2 is you just take the body, make it reach point C. After that, the body may not complete the circle ahead of it. Okay? That means body reaches point C, stops, and then falls vertically. Okay? During SL World ride, Imagica rides, you might have seen that. There are SL World, I remember, there is a Thunder ride where there are people who are at this position of, means there is a huge rod and people are actually inside a cage here, and they actually take you to the topmost point where your body, right now we are standing like this. Just imagine we are standing. Sorry, we are sitting like this. Just imagine we are sitting, but our head is upside down. Just imagine ourselves upside down. So you will be at position C, upside down like this. So your head will be here, your legs will be like this, and they stop it there. You stop at point C. So what is that minimum velocity with which I should shoot a body at point A? It crosses B, reaches C, and stops. I hope the objective is clear. In situation number 1, the velocity at C will not be equal to 0. Rather, it will be minimum velocity that I want to find out. And at C, in case number 2, the velocity at C will become 0 because the body stops there momentarily. After that, it falls down. Okay, guys. Hope the objective is clear. First, we'll speak about finding these two things. Okay. 1 second happened. End of the story. Okay, guys. Now, we want to talk about objective for situation number 1. First situation पे चलते हैं. And the situation number 1 awaits us here. So we have situation number 1 where we want to find out the minimum velocity at A, B, and C, and we also want to find out the tension in the string at point A, B, and C, for which the body just completes the circular motion. Okay, just circle is completed over there. So everyone, the first thing that you will do is to speak about point A and C, and let's talk about the energy between A and C being equal. Honestly speaking, guys, very honestly speaking, today I'm doing this after years, I guess. It's been a long time that I've done this derivation. I'm completely relying on my own learning. I have not gone, there was a complete properly made slide. It was not in sync with my learning. So that's why I am doing this derivation in front of you. And so that I don't remember exact process by which I used to go earlier, but definitely will reach there. My promise to all of you. Okay, people. So at A and at C, I'm applying law of conservation of energy. The energy of the body at A and the energy of the body at C will be same. I have considered point A to be at 0 height. So at A, the body will have no potential energy. The body will have half mVA square kinetic energy, half mv square, right? At C, if the radius of the circular path is r, okay, if the radius of the circular path, so small r like that, so the height of the body from A has become 2r, and kinetic energy, the body is not stopping there. Remember, at C, the velocity is not 0. Will be half mvc square. Okay, guys, cool. Now, what do I do? Obviously, m cancels throughout. You see that? M will cancel throughout. So m got cancelled. And now what? I can multiply both sides by 2. When I multiply both sides by 2, it is VA square, which is equal to 2 times 2RG plus VC square. That means what, everyone? VA square comes out to be VC square plus 4RG. This is our equation number 1. This will help us correlate velocity at A and velocity at C. इनमें से जहाँ की भी velocity मुझे मिल गई, if I got the expression of VA, I'll be able to get the expression of VC. If I get the expression of VC, I'll be able to get the expression of VA. Okay, everyone? Keep your doubts. Keep your doubts. I will clarify all of them. Though I'm not doing anything so extraordinary that you don't understand it. This is only law of conservation of energy applied. Now, everyone, at C, सबसे पहले C point पे जाएंगे, because we want to talk about the minimum speed here. So first, let's talk about the forces which are acting on the body at point C. So definitely, body is experiencing two forces there. One is tension, the other is mg. Both the forces are acting towards the center. Look at this. Tension is definitely acting on the string. Mg is definitely acting downward. I told you there are only 2 points where mg comes on the radial direction. C is one of them. So at C, we can say that the tension force Tc plus weight of the body mg, both are acting towards the radial direction and should be equal to mvc square by r. Okay, everyone. And guys, we want vc to be minimum. We want the minimum value of velocity for which the body is able to complete the circle. The body completes the circle as long as it experiences a centripetal force. Everyone, when vc becomes minimum, can mg value become anything other than what it is? Can mg value change? Or can I say mg is already a constant? Mg is constant. So tension has to adjust. What is the minimum value that tension can have? Can I say the minimum value that I can bring tension to 0, right? So for VC to become minimum, tension has to become 0. And when tension becomes 0, for that small instant of time, it's a very small instant when the body is going to cross that point C, mg will behave as mv square by r for a very small instant. Are you guys getting it? Feel it? Okay. Therefore, 0 plus mg will be equal to mvc square by r. By the way, this VC is now VC minimum. This is VC minimum. I'm not writing it as VC minimum, but this is VC minimum. Okay, everyone? So m cancel ho jata hai. What am I getting VC square as? VC square comes out to be RG. Have we got the value of VC minimum? Under root RG, we get it. Okay, taking it on the other slide for all of you. VC minimum came out to be under root RG. Okay, fraction of seconds. Obviously, the body will not stay there. It has to move on. It has to move on. But okay, v will not be equal to 0. Definitely, v कहाँ 0 हो रहा है? अगर v 0 हो गया तो फिर तो गेम खत्म हो गया. फिर case number 1 रहा ही नहीं, वो case number 2 हो जाएगा. Okay, everyone, awesome. And now I have equation number 1 waiting for me because this will give me the value of va. Okay, so this is a very important expression. This is the minimum velocity with which the body should reach the topmost point. Remember this value, very important it is. And now put in equation 1, which was va square equal to vc square plus 4rg. So put करो, va square will be equal to rg plus 4rg. I get the value of कितना आ गया everybody? va minimum कितना आया? Under root 5rg. ये इतना important expression है, I can't tell you guys. ये इतना important result है. JEE may give you questions which will directly be based on this formula or application of it. इतना ज़्यादा important है. और derivation के नाम पे कुछ भी challenging नहीं है. It is very straightforward. It is very straightforward. Okay, guys. It's called the minimum velocity required at the bottommost point. This is the bottommost point velocity required by the body to just complete the circular path. If you throw a body with this velocity, if you shoot a body at the bottommost point with this velocity, the body will be able to not only reach point C, but will also be able to successfully complete the circle. Okay? नहीं ये minimum है बच्चा, minimum है. इससे ज़्यादा से भेजोगे तो obviously circle complete हो जाएगा, पर minimum इतनी चाहिए. Okay? Story is not done yet. Story is not done yet. Okay? अब हम क्या करेंगे? हमने A और C पे तो पता लगा लिया. B बचा हुआ है. B is left. Okay? Everybody? B is left. तो चलो. For B, I will say energy at A equal to energy at C is equal to energy at B. ये क्या है? ये है law of conservation of energy. एक और बार लगा रहे हैं. तो अब चाहिए तो EA equal to EB कर दो और EC equal to EB कर दो. Totally your call. You want to equate energy at D and C. You want to equate energy at A and D. Totally your call. तो किन दोनों पॉइंट्स के बीच में करें? AC और BC. Sorry, AC or AB or CB. AB or CB. These are the two options. CB. चलो CB करते हैं. चलो CB कर लेते हैं. कोई दिक्कत नहीं. Let's do that. So we are going with these two. Energy at C. The potential energy at C is m into g into 2r. Kinetic energy is half m vc square. Energy at B, potential energy will be equal to mgr. There is not zero potential energy. This height is equal to r, and this height was equal to 2r. Getting it, everyone? So that is why potential energy mgr, kinetic energy half m vb square. तुम क्या करोगे? Vc का minimum value you will put here. You'll put the minimum value of Vc here. M तो already cancel हो रहा है. You will be able to see m getting cancelled. You will simplify it for Vb minimum, and you'll find out. Anybody found it already? कोई कर रहा है मेरे साथ? Anyone did it? If you will simplify this, you will get the value of Vb minimum as under root 3rg. This is what you will get. This is what you will get. Okay? Yes, guys. That's our final result. और बहुत symmetric order है. It's a very symmetric order. Bottommost point root 5rg, middle point root 3rg, topmost point under root rg. अच्छा, if you want, you can check for D point also. D and B will have the same energy. D and B will have the same energy. Okay? Adesh, it will not happen, bacha. Body will not fall down. At D, the energy, potential energy same. At D, potential energy same as that of B. Both are mgr, correct? So definitely kinetic will also be same because energy at D is also equal to energy at D. So potential be same, kinetic be same. Cool. Okay. Tension can become zero. क्यों? String थोड़ी देर के लिए zero tension रख सकती है. It's happening for a very small fraction of time. Okay. Cool. So this is done. अरे वाई, क्योंकि ये कंडीशन सेटिस्फाई होनी चाहिए, इसलिए वाई ये मिनिमम केस है, हर बार जीरो नहीं होगी टेंशन की वैल्यू एट सी। इफ योर बॉडी रीचेस पॉइंट सी विद वेलोसिटी जिसका एक्सप्रेशन अंडर रूट आरजी आता है, देन द बॉडी विल हैव मिनिमम वैल्यू ऑफ टेंशन एंड दैट इज जीरो। ओके, यस, वीबी इज इक्वल टू वीडी, वीबी इज इक्वल टू वीडी एट एनी सिचुएशन। ओके गाइस, cool, chalo, now as I said we will find out the value of tension also, so फटाफट से tension पता लगाते हैं for point C. Okay, at C we have to first of all draw the forces obviously, so you will see that this is tension TC, this is tension TA, and this is tension TB. Obviously tension is acting on the string and string is connecting the body to the center. Let's look at the gravitational force. So this is mg acting downward, this is mg acting downward, and this is mg acting downward. mg का डायरेक्शन चेंज नहीं हो रहा है, टेंशन का डायरेक्शन चेंज हो रहा है। so all of you look at the three situation. Okay, so at C, we have written the equation earlier also, TC plus mg is equal to mvc square by r. Okay, and what we considered, we saw that TC का value will be equal to 0 for minimum case, obviously for minimum case. Okay guys, this is minimum case, maximum हम define नहीं कर सकते। Okay, at B TB is the only force acting towards the center. Do you guys see that? Do you see that at B TB is the only force acting along the radial direction, so that is why it is mvb square by r. And what was the expression of VB? Minimum value of VB was कितना rg, अंडर रूट में कितना rg at D, root 3 rg, perfect. So m square करूंगा तो root 3 rg का square divided by r, r and r cancel, we get 3 times of mg. We get it everyone? 3 mg आता है value, space बचा के लिखता हूं ताकि एक ही लाइन में आ जाए। m into 3 rg by r comes out to be 3 mg. This is tension at B. And at A tension TA is acting towards the center, TA opposite to the center is acting another force, that is mg. Are you guys getting it? Radially outward, mg is acting radially outward at A, trying to oppose TA, should be equal to mva square by r. So TA का value कितना आएगा? mva square by r plus mg. Okay, and yes, root 5 rg, so this will be 5 by m by r, 5 rg plus mg comes out to be 6 mg. Look at the difference, 6 mg 3 mg 0. This gap of tension will remain the same, you can try with any other value. अगर topmost point पे tension mg ले लिया, for example अगर topmost point पे tension mg आ रहा है तो b point पे 4 mg आएगा और a point पे 7 mg आएगा. You can check it, you guys can check it, okay, by applying the same thing. Okay, I don't call it periodicity. So guys, results are very important, the three values of velocities are most important. Okay, Samarthika ask me towards the end. Okay, आर्यन, हम सेंट्रीपिटल फोर्स लिख रहे हैं और सेंटर रेडियल डायरेक्शन में लगने वाला फोर्स एट बी इज ओनली mg. यहाँ पे यही तो समझाया था, यहाँ पे पूरी कहानी यही तो समझाई थी कि रेडियल फोर्स शुड बी इक्वल टू mv स्क्वायर बाय r. तो रेडियस के डायरेक्शन में लगने वाला फोर्स ढूंढना पड़ेगा, रेडियस के डायरेक्शन में लगने वाला फोर्स एट बी इज ओनली tb. ठीक है, सो दिस वाज योर केस नंबर 1, यू हैव सीन सिचुएशन नंबर 1. नाउ विल मूव टू सिचुएशन नंबर 2. ओके, कूल एवरीवन. मैं जो इतनी देर से बोल रहा हूँ वो मैं चाइनीज में बोल रहा हूँ, क्या लास्ट ये बीच की बात है. मैंने बताया बीच को मिनिमम होने के लिए टेंशन को जीरो होना पड़ेगा. ओके, व्हाई? बिकॉज़ mg जीरो नहीं हो सकता, इसलिए. सर इज एनर्जी एट ए इक्वल टू एनर्जी एट सी, क्यों? ये क्या मैंने चाइनीज में लिखा है? इज दिस चाइनीज? हाँ, इज दिस चाइनीज और जापानीज और संस्कृत? या एनीवेज मुझे मालूम है बहुत सारी लैंग्वेज एग्जिस्ट करती हैं. सो लेट्स क्विकली गो टू सिचुएशन नंबर 2 एंड वी हैव द सेम ऑब्जेक्टिव, बट दिस टाइम द लाइफ इज इजियर. VC का वैल्यू इज 0. व्हाई? बिकॉज़ द बॉडी जस्ट रीचेस द हाईएस्ट पॉइंट ऑफ ट्रैजेक्टरी एंड स्टॉप्स. इफ इट इज कनेक्टेड बाय अ स्ट्रिंग, स्ट्रिंग विल बिकम लूज, वेलोसिटी बिकम 0, बॉडी फॉल्स डाउन. सो एवरीवन क्विकली, हमें ऑलरेडी VC तो मिल गया, VC मिनिमम इक्वल टू 0. एंड नाउ लेट्स इक्वेट एनर्जी एट A एंड एनर्जी एट C. पहले A पे निकाल लेते हैं. सो H equal to 0, you see that at A the potential energy is 0, kinetic energy is half mva square. At C potential energy is mg2r, this is r, and kinetic energy becomes 0. Why? Because velocity at C is 0. ठीक है, बताओ सिंप्लीफाई करो कितना आ रहा है एवरीवन, डू दिस क्विकली, ये तो बहुत इजी है, अब तो बहुत इजी है. va square comes out to be 2 into 2 4rg, va minimum comes out to be under root 4rg. You can write it as 2 into under root of rg, but we are calling it root 4rg. Okay guys, I'm deliberately calling it root 4rg. So this is C का minimum velocity, A का minimum velocity. Any guesses for B? Any guesses for B? पिछली बार root 5, root 3, root 1. अभी root 4 और 0 के बीच का वैल्यू क्या root 2 rg आएगा? देखते हैं क्या root 2 rg आएगा. We'll see that. So let's equate energy at B equal to energy at C. At B the potential energy is mgr, kinetic energy is half mvb square, and potential energy at C is mg into 2r plus kinetic energy 0. तो ये 2 mgr को यहाँ लेके आ जाओ तो mgr बचेगा. अगली स्लाइड पे जाना पड़ेगा बेसिकली. So we have half mvb square equal to 2 mgr minus mgr, m cancel, vb square by 2 is equal to 2 rg, vb square equal to 4, what? I made a mistake, equal to rg. So vb square comes out to be 2 rg and vb minimum as expected came out to be root 2 rg as expected. सब लोग खुश, पैटर्न भी मिल गया याद रखने के लिए. root 4 rg, root 2 rg and 0. And by the way all of you, this will also be equal to vd minimum. This will also be equal to VD minimum. बता चुके हम लोग ऑलरेडी. D is identical point as B. It is only B पे बॉडी ऊपर जा रही है, D पे बॉडी नीचे आ रही है, और जो भी है उल्टा हो रहा है. B और D पे चीजें जस्ट उल्टी हैं in terms of direction. Okay? Tension. Let's find out tension also. So everyone, tension बिल्कुल नहीं है लाइफ में. ऐसी सिचुएशन समझ में आ जाए तो कोई टेंशन नहीं है ना. तो ये है टेंशन एट A, टेंशन एट B, और ये है टेंशन एट C, और mg. This is mg, this is mg, and this is mg. Okay, so at c tc plus mg equal to 0. मतलब क्या, ये तो ये बन गया tc plus mg equal to 0 आ गया. That means what? Can you be a bit slow in terms of me speaking or me doing things? tc equal to minus mg. इसका मतलब एक्चुअली बोलूं इसका क्या मतलब है? इसका मतलब ये बच्चों कि if you are talking about a string, then the tension will actually become 0 much before point c. Obviously tc cannot be equal to minus mg, और tc का tension का direction opposite भी नहीं हो सकता. Listen to this point very carefully everyone. What does this mean? Practically tension and mg are definitely along the same direction, so direction तो different नहीं कर सकते. What it means, it is suggesting you that tc is equal to minus mg. इसका interpretation याद रखना पड़ेगा तुम्हें, that the tension value has actually become 0 much before point c. Tension will become 0 somewhere here only in the string, but the body will be able to reach point c because of the momentum it already has. It has some momentum already. और देखो अगर बॉडी यहाँ पे है और इस पे टेंशन 0 हो चुका है, there is mg acting on the body, और mg का एक कंपोनेंट है which will provide it the centripetal force. If this angle is theta, you can see that there is mg cos theta force which is acting towards the center. Are you guys following me? Tension has actually become 0 much before point c. It is mg का one component which is providing it centripetal force and bringing it to point c and then stopping it. Okay, you'll have to remember it. Actually tc पे tension 0 है, याद रखना पड़ेगा ये बात याद रखने की है. Okay everyone, so at c please remember body moves due to velocity and inertia both, you can say that. So at c please remember tension is 0. Okay everyone, लिख दिया मैंने, tension is equal to 0. Okay, yes. Okay, at b tb is equal to mvb square by r, और vb का मिनिमम वैल्यू क्या था? vb का मिनिमम वैल्यू था 2rg. ओके, vb मिनिमम वैल्यू अंडर रूट 2rg, स्क्वायर करोगे r और r कैंसिल करोगे, 2mg is the minimum value of tension. Okay, and at a ta minus mg is equal to mva square by r. So ta is equal to mg plus m 4rg by r. तो ये कितना हो गया? 5rg. Okay, actually tension का expression is not that important. Expressions of velocities are very important, and remembering the condition is the most important. Remembering the conditions are the most important things. What is happening when the body is just completing the circle? Okay, I should actually say here the body will not even be able to complete the circle. Okay, in this case body will not be able to complete the circle. Understand this part guys. ये बहुत बड़ा point है जो मैं end में बताना चाहता था एकदम. Because the body is stopping at c. It's not even going ahead. Are you getting it, everyone? The body is not even going ahead of that. Okay. ये समझ बेटा. That's what is happening. The body will, if it is string connected to a stone, the body will fall from point c vertically downward. Okay, is that clear everyone? Now as if you guys, because you guys are making a lot of noise in the chat box, and for once please listen to me carefully. Listen to me carefully. Forget about asking this doubt to your class teachers. Forget about writing this point. For once write it here. I'm explaining this for the last time, that why tension at c in both the cases is 0. Listen to me carefully. इसके बाद बताऊंगा नहीं, ये भी बोल रहा हूँ. Listen to me carefully. Here, first of all, remember what question is asking or what situation is. Situation is, we want the body, in case number 1, situation number 1, we want the body to start from A, reach point C, and still move ahead and complete the circle. Okay, still move ahead and complete the circle. Like a stuntman may be able to do that in a vertical circle. So at C, if I want the body to complete the circular motion, then if I look at the most critical point is point C, right? So at C, when I wrote the equation of centripetal force, look at the diagram. Look at the diagram and look at the force which is acting on the body at C. Tension is acting downward in the string because C and O are connected by string points, and body is at C and O is the center. So O and C is actually the length of the string, and there tension is acting, right, trying to pull the body. Mg is acting downward. Both the forces are acting downward, and that too towards the center of the circle. That's why tension plus mg is equal to the centripetal force mvc square by r. And if I want vc to be minimum, I want vc to be minimum. Definitely, if right hand side has to be minimum, left hand side has to be minimum. For left hand side to be minimum, either mg has to achieve its minimum value, but you know that mg is not going to change its value. It's constant on Earth's surface. So it's tension which is going to sacrifice its value, and the minimum value that you can expect in the string will be 0. The minimum value is 0. Happens only for a small instant when the body is crossing the topmost point. Okay, and that is why you have equated the tension at C to be 0. Okay, that's why your equation becomes 0 plus mg equal to mvc square by r. Hence tension is 0 to make minimum centripetal force, to make velocity minimum. Okay. Are you saying that, sir? Are you saying that the vertical circular motion happens only when the topmost point has 0 tension? That is not what I said. I said for topmost point to have minimum velocity, minimum means what? I'm basically having a stone and a thread connected here, and I'm giving it a velocity. Okay, so when I give this body a velocity like this, it goes ahead, comes back, goes ahead, comes back, goes ahead, comes back, goes ahead, comes back. If I keep on increasing the velocity with which I'm actually throwing it up, with which I'm actually pushing it ahead, there will come a point when the body will go up, will reach somewhere here, will come back. So there is a minimum velocity for which the body will reach to the topmost point and will not fall down. And for that, the tension has to be 0 at the topmost point. If I will throw the body, or if I will shoot the body with a velocity which is much higher than the minimum values, then at C also the tension will not be 0. For minima case, the tension will be 0 at point C. Okay. In the second situation or second case, why the tension at point C became 0? Okay, this was still case number 1. This is situation number 2. At C, the velocity has to be 0 because in this case, we want the body to only go to the topmost point and just stop it. Stop there. If the body stops there, and if it is a stone which is connected by a string, it will fall. Simply सोचो ना, हिंदी में भी बता देता हूँ. अगर एक धागे से एक स्टोन को कनेक्ट किया, एक पत्थर को कनेक्ट किया और उसे वर्टिकल सर्कल में घुमा रहे हो ऐसे, तो एक ऐसी सिचुएशन है जिसमें बॉडी टॉपमोस्ट पॉइंट पे जाए और रुक जाए. तो रुक जाने के बाद में क्या होगा? गिर जाएगा. So that is why the velocity at C has to be 0. और अगर velocity at C 0 होती है, and if you try to write that equation at this point, that Tc plus mg should be equal to 0, तो फिर ऐसा लगता है कि टेंशन और mg दोनों माइनस हो रहे हैं एक दूसरे के. Tc minus mg के बराबर आ रहा है, जो practically possible नहीं है. तो इसका interpretation, the interpretation of this thing is very important. That maybe at some point P before C only, when the body was going from B to P to C, there came a point P where tension already became zero. String already lost its tension. But then why did the body go to point C? The body went to point C because the mg force which is acting on the body, it has one component which is still acting towards the center, behaving as centripetal force. Tension became zero. For a body to move in the vertical circular path, it is not only tension which is responsible all the time for the body to have a centripetal force. Even mg can provide a centripetal force at times. That's why. Okay, guys. Please बोलो क्या समझ में आ गया, प्लस 1 लिख दो चैट बॉक्स में. ठीक है, great. Yes, it is easy and it is important. It's because from a very important topic. Okay, guys. चलो, switching on the chat. Okay. Yeah. Sir, can we somehow find that point where the tension became zero in the second case? हम end में बात करते हैं point के बारे में, मुझे भी thought देना पड़ेगा, तो end में thought देते हैं, ठीक है? Now guys, different situations वापस से recap कर लेते हैं. If you throw the body from bottommost point at the lowest point, if you throw a body with a velocity which is greater than 5 rg, then what will happen? The tension in the string will not become zero at any of the point which I just now said. That even at C also the tension will not become zero, because now the body does not reach C with the minimum velocity. Because at C now the velocity will be more than 2 under root rg. Okay? If you throw the body, or not throw actually, you project the body with under root 5 rg, at C the tension becomes zero. We know this. If you project the body with a velocity which is between under root 2 rg and under root 5 rg, we'll speak about this, but first we'll speak about this point. If your velocity of the body is under root of 2 rg, you can try this value. The velocity under root 2 rg comes when the body will be able to reach at point B and stops. If you will throw a body with a velocity under root 2 rg, if velocity at A is under root 2 rg, you can try applying energy at A equal to energy at B. You will find that body will have zero velocity at B. Okay, everyone? So body at B will stop. Why? Because its entire kinetic will become potential at B. So both velocity and tension in the string will become zero, which was happening at C when you were throwing it with under root 4 rg. Okay, so both tension and velocity become zero at B, and also particle will oscillate and will oscillate in the circular motion. Means B to D, D to B, B to D, D to B. That is the kind of oscillation which will happen if you throw the body with velocity under root 2 rg. But if you have a velocity which is somewhere between under root 2 rg and under root 5 rg, then what will happen, guys? Your body will be able to cross point B, will be able to reach here, maybe at point P. But from there, the body will slack, string will slack, the body will fall, and then it will oscillate. The particle will not follow circular motion. Tension in the string will become zero somewhere between B and C, and the velocity will remain still positive. The particle leaves the circular path, follow a parabolic trajectory. That means the body will fall like this. ऐसा कुछ होगा. Okay, everyone? Because it will still have some velocity. Its tension will become zero, and it may fall, and the body will start moving. Okay. Cool. What if you project a body with a velocity less than 2 rg? Under root 2 rg was required to take the body to B. Now body will not even reach B because you have given it a velocity which is not even sufficient for the body to take it to B. Okay, so body will reach somewhere here and stop and will start oscillating. Okay, so velocity of the particle becomes zero between A and B, but the tension does not become zero and the particle will oscillate about point O, like this. It will go like this. Okay, guys, I hope you guys have gone through the situations with me. The last few situations are not very important, that you will get a feel of when you are solving the problems. And already we are now left with only 45 minutes of the class. So I want us to do problem solving, which is very, very, very important for us. So let me quickly show you examples, and then you guys have a lot of problems to solve. Question says, this is our very first question. Keep your doubts. I will answer them after the class ends. Okay. A particle of mass m tied to a string of length L and given a circular motion in the vertical plane. So body को हमने L length की string से connect किया, mass of stone, made it to move in the vertical plane. If it performs a complete loop motion, then find the difference in the tension at the lowest and the highest point. We already know that tension at A, अगर हम minimum case को ही case मान लें, tension at A came out to be 5 mg, right everyone? Or 6 mg, sorry 6 mg it came out to be. And tension at B, as per this, I'll have to call this point as B, and I will call this point as C. So tension at B is 3 mg, and tension at C was 0. This was the minimum case. So what is the gap between tension at A and C? You can see this directly. Right, everyone? So what you see here, the gap is 6 mg, and answer is 6 mg. No doubt about that. We know this already by the minimum velocity case. But let's try to talk about any generic case when the velocity at A is not the minimum velocity you want to throw it with. So at A, say the velocity that you give to the body is u. Okay, and at topmost point, we are calling that point. Okay, this one is the lowest point. This is the highest point. So L and H. At L, I'm talking about the tension force. You know that tension minus mg is equal to mu square by r or mv square by r. Okay, you all know how to write this equation now. It was TL minus mg equal to mu square by r. Mg got to the right hand side. So this is at lowest point, and at the highest point, tension plus mg equal to mv square by r. So mg comes to the right hand side. We have mv square by r minus mg. Instead of r, we are writing it as L. Okay, guys, this is the equation of tension. If we talk about the law of conservation of energy from here, we know that half mu square, and basically I will write it in the way I write it. At A, at L, we are basically trying to write the energy at L and energy at H. So at L, the potential energy is 0, kinetic energy is half m u square. At H, potential energy is 2 mg L, and kinetic energy is half m v square. Okay, guys, so we will be using these two equations. From here, our objective is to find out the difference, right? So we will do TL minus TH, lowest point minus highest point. When we will do that, we will see that the equation will come out to be this. You can try this. TL minus TH, the difference will be mg minus mg will become mg plus mg. So 2 mg plus m by L u square minus v square. That's the equation that we should have on the right hand side. Okay, guys. Okay, they have eventually used the minimum case only. They have gone with the minimum case. Anyway, so we have done the derivation already. Okay, everyone. So we actually got the derivation done earlier. So we have this value already. Not a problem. ठीक, तो मेथड भी समझ में आ गया. अगर हमें value of v और u दिया होगा तो भी आंसर आ जाएगा. ठीक है, everyone. Do we understand this? They have used the value of u as under root of 4gl. They are considering that the topmost point the velocity will become. अच्छा नहीं नहीं मैं फिर भी इससे नहीं जाऊंगा. Let me correct it. मैं फिर भी इससे नहीं जाऊंगा. मैं लिखूंगा जो मैंने वहाँ लिखा है 2mg minus plus 2mg plus m by l u square minus v square. That's the equation I wrote it here. ठीक है everyone? u square minus v square perfect exactly. और u का minimum value हम लेंगे under root 5gl. हम r की जगह l लिख रहे हैं यहाँ पे. करके देखें everyone. So 2mg plus m by l u square is 5gl. Can you people tell me minimum value of v? Under root rg था. तो 5gl minus gl, l और l cancel हो जाएगा. We have 2mg, okay, plus 4mg. The value comes out to be 6mg any which way. मिनिमम केस लेके गया, easiest है वो हमारे लिए, क्योंकि किसी भी और वैल्यू के लिए you will require the value. R is equal to L. The length of the string is the radius. Okay. So do we have to memorize the minimum and maximum case? Yes, the results are very important. You have to memorize. Okay, you have to memorize. Directly substitute. Perfect. Chale, let's start the quizzes. Everybody, ready? Don't worry, I'll keep on telling you the formulas if required. Okay. Don't worry. Everyone. Question in front of you. It says that the bob of a simple pendulum of length L has a mass m. That means radius is equal to capital L. If the bob is given a velocity which is v, okay, and this velocity is less than under root of 2gl. Less than under root of 2gl का मतलब होता है, guys, what does it mean? That the bob will not be even able to reach point B. It will not be even able to reach point B. Whatever be the velocity with which you are launching it, it is so less that the body will not even be able to reach B. It will stop somewhere here at point P and will start doing oscillations. But before oscillations, the body will stop at a maximum height h. So you have to find out what is the value of this h. This h below the value of height where your body will go and stop is what you have to find out. Hope the question is clear, everyone. You'll get 45 seconds. Very easy question. Okay, simple law of conservation of energy, and your time starts in 3, 2, and 1. Come on, people. Common sense. Okay, and the time's up. You'll be surprised to know the solution is super duper easy. Everyone, simple law of conservation of energy. Whatever is the energy at bottommost point will be the energy at point P also. Na? Energy at A should be equal to energy at P. And for that to happen, at A, zero potential energy, kinetic energy is half mv square. At P, you have zero kinetic energy because the body will stop at point P, right? And potential energy will be mgh. Question is asking for that height. So m or m cancel hota hai. H comes out to be v square by 2g. That's your answer. Got it? Easy, everyone? Common sense. Cool. Okay, now this one is challenging. This one is challenging. This says that we have a particle which is moving along a vertical circle of radius r at point P when the body is reaching. What do you think will be the velocity of the body at point P when you have to assume critical condition at C? What do we mean by critical condition? I have explained that in the blue color. By critical condition, we mean that the particle which is moving in the vertical circle when reaches point C, its velocity will be just a second. Is it zero? Just a second. Let me check. Just a second. रुको, मेंटल कैलकुलेशन करनी पड़ेगी. ये क्वेश्चन मैं नहीं दे रहा हूं तुम्हें क्विज की तरह because critical condition नहीं है. ठीक है? Everyone, not giving you guys this question as your critical condition case is not clear. That's why I'm not giving it as a quiz. So everybody, if we go by this, which you see as the condition that I've written, I don't know why did I write that. I might be thinking about something. So if I'm going by that condition, that at C the velocity becomes zero, if I'm considering the second situation as the critical condition, okay. So wait and watch. I will explain you once I'm done. So it is. Just a second, people. So at A, it is half mva square equal to half mvp square plus m into g into h. और ये height होगी r by 2 and r. That means 3 r by 2. So mass cancel हुआ, 2 cancel हुआ. If this is 4 rg, this is vp square, this is 3 rg. Then oh sorry, I have actually written the wrong critical condition. अच्छा मैंने quiz नहीं दिया तुम लोगों को. I have not written the critical condition right. Will become under root rg. That is why I was confused. So sorry guys. Maybe in some momentum I might have missed it. ठीक है everyone? बहुत अच्छा question है. So let me explain it to you all. The velocity at C, when we speak about critical case, is not zero, it is under root rg. Remember that, everybody. Whenever that critical condition word comes, we are basically talking about velocity at A to be under root of 5 rg and velocity at C to be equal to under root of rg. That's basically what we mean by the critical condition. Now, everyone, we want to find out what is the velocity with which your body is crossing a random point P for which the location is such that the radius is making an angle of 60 degree. ठीक है, everyone? तो इसको simplify करते हैं. I will take this diagram on a new slide and I will explain it. So pay attention, everyone. It's a real good question. Yes, critical condition means at the bottommost point under root 5 rg, at C under root rg. So everybody, at A we know the velocity. We are considering height to be zero. The only game is actually about this point P. So first focus on this point P. You see that this is point O and this is radius, that is capital R. And you see that this angle is 30 degree. So I'm taking this triangle out. This is P, this is O, this is not B, but this is R, and this angle is 30 degree. Okay guys, so I'm calling this point as B dash, and this is point B, P and B dash at a distance Y. Here, why am I doing this is basically I want to find out the height of point P. ये बता देता हूँ कि क्यों कर रहा हूँ ये. I want to write down energy at A equal to energy at P. Energy at A will be zero potential energy, half mva square kinetic energy. At P, I will have potential energy that is mgh, and that is what I need. I need the height. So already this distance is r, but what about this distance? This distance is y. So y मिल गया तो पूरी height मिल जाएगी. Okay guys, and kinetic energy will be half mvp square. तो vp आ जाएगा. ठीक है guys? So that is why. From here, let's do this. Here I can see that sine 30 degree is equal to y by r, and that is equal to half. Sine 30 is half, so y is basically r by 2. Good enough. So you will be putting it here. Let's write r plus y, right? H is equal to r plus y. Okay guys, so putting y की जगह पे r by 2, and that comes out to be r plus r by 2, that is 3r by 2. That's the height of the body at the moment. So that means energy at A equal to energy at P is half mva square equal to mg 3r by 2 plus half mvp square. 2 will be cancelled and m will also be cancelled. Are you guys with me so far, everyone? Are you all with me so far? m cancel कर रहा हूँ and 2 cancel कर रहा हूँ, ठीक है? Yes. Good, thank you. So VA का minimum value under root 5 RG, right? So square कर दिया. This is 3 RG and this is VP square. Can you people now tell me VP square का value under root 2 RG? So VP comes out to be, so VP square is 2 RG, so VP का value under root 2 RG आता है. That's why the answer is under root RG, 2 RG. So why did you use the formula H equal to R1 minus cos theta? You can use that. Yes, you can directly use that formula also. Okay, guys, this is definitely JEE level यार. ये question देख के भी तुम्हें JEE feel नहीं आ रही है. This is JEE question. This is JEE level. Okay. Okay. चलो. चलो guys, questions, more questions now for all of you guys. Okay. अरे यार मोनीश कैसी बात कर रहे हैं मेरे भाई? ये height का value y plus r है ना? मोनीश, this height is radius plus y value and y value came out to be r by 2. So r plus r by 2 is 3r by 2. Sometimes you actually guys give me a complex that sir what you write sounds and looks Chinese. हाँ? मोनीश clear हुआ? Thank you. Chalo guys, question in front of you. A stone of mass 1 kg is tied with string and it is whirled in a vertical circle of radius 1 meter. If tension at the highest point is 14 Newton, then the velocity at the lowest point will be how much? Question is nowhere saying that the velocity at C is minimum or critical. कुछ नहीं बोला ऐसा. इसीलिए I have given you the hint. At C, two forces are acting, mg and tension. At A, you are considering height to be 0. So use this as your equation number 1, this as equation number 2, and tension at C plus mg will be equal to mvc square by r. यहाँ से vc मिलेगा. और फिर energy at C and A को equate करना, वहाँ से energy से velocity at A मिल जाएगा. Giving you guys full 2 minutes to try this. This is a good question once again. It's a real good question, and without hint, it would have been very challenging. Hence, I've given you the hint, and your time starts in 3, 2, and 1. One minute gone, one more minute left. Come on everyone, 20 seconds remaining. Steps are already there, just have to solve it. Solving speed बढ़ाओ. Very less number of people answered it. Okay, hands up and let's see how many people got this right. क्या यार? Why? What just happened? कहीं ऐसा तो नहीं कुछ ऑप्शंस में गड़बड़ है? देखते हैं. कहीं ऐसा ना हो यार. That would be really scary for me. But let's see everyone. तो पहले ऐसे ही चलते हैं. Tension at C is 14. Mass of the body 1. G value is 10. Mass of the body 1. Radius is 1 and VC square. This comes out to be how much? 24. So VC square का value comes out to be 24. I'm keeping it as this only. ठीक है guys. Now second thing, as I said, energies will be equated. Energy at A will be equal to energy at C. So half m VA square plus 0 will be equal to mg into 2r plus half m VC square. तो m cancel कर दिया मैंने और मुझे मिलता है VA square will be equal to 2 से मल्टीप्लाई कर रहा हूँ both side 4rg plus VC square. ठीक है. So VA square equal to 4rg plus VC square. 4 r value is 1, g value is 10 plus the value of VC square. Everyone, value of VC square is 24. तो कितना आ रहा है? 40 plus 24 is how much? 64 ही होता है यार ये. यही गलती हुई होगी मुझसे. And what is under root of 64? 8 आता है ना? कुछ गलत नहीं है ना? Correct? मुझे डर लग रहा था because earlier the options of these questions were not right. I'll show you that. Earlier these were the options and option D was marked as the correct answer. जबकि correct answer is 8. Okay. चलो moving on. One more. Quickly. A particle of mass 200 grams is whirled in a vertical circle of radius 80 centimeters. ध्यान देना, values of units are in CGS unit system. The speed of the particle when the tension makes an angle, when the string makes an angle of 60 degrees with the vertical is 1.5 meters per second. This is the situation. I've given you the forces also. I've drawn the forces also. The tension in the string at this position will be how much? I have kind of explained the situation to you in the beginning today. I've given you this explanation already. Okay, everyone. So you have to talk about the velocity is given, theta is given, tension का value पता लगाना है. That's what you have to do here. Okay guys. Velocity का value is 1.5, angle is 60 degree. Try to write the equation of centripetal force and then simplify for the tension at that point. Giving you guys 2 minutes and your time starts in 3, 2, and 1. Excuse me. 45 seconds remaining. Last 15 seconds now. Okay, and good number of people. Very good. So guys, this is that component mg cos 60 degree. So how will I write the equation? I will write the equation as T minus mg cos 60 degree equal to mv square by r. Correct? So tension का value क्या हो गया? mg cos 60 का value. What is cos 60? हाँ, right. So mg by 2. mg by 2. This comes here, right? So plus हो जाएगा. And mass taken common mg by 2 plus v square by r. Let's simplify it on the next slide. I have tension. Mass of the body is 200 grams. 1000 से divide. G value is 10 by 2. Okay, this is the equation that we are following. So 10 by 2 plus v, velocity is 3 by 2. 3 by 2 का square 9 by 4, right? So 9 by 4, how much is the radius? 80 centimeters. Meter में convert करना पड़ेगा. So this cancels 5 by 4 times 20 से divide कर दिया. This cancels. I have 2 by 10 and everything cancelled. This is 1. This is going inside, by the way. 2 by 10 is going inside. Plus, this will be 9 by 16. So I'm getting it as 16 plus 9 by 16. Do the maths. मुझसे मत पूछना सही स्टेप्स कैसे आ रहे हैं. Okay, this will be 1.65. गड़बड़ हो गया क्या? 1.56 आता है. सही है ना? कौन सा 5 डिनोमिनेटर? m taken common यार, m taken common. v square by r not understood. अभी समझ में आया? Okay, got it. मैं अकेला नहीं रहता. Answer is 1. अच्छा. Kamal Thomas, maybe in some parallel universe with Rajinikanth Institute of Technology, you will get the answer as 1. So what is 25 by 16? 25 by 16 is a fraction studied in mathematics. Okay. Chalo, one more. Quickly, everyone. Quickly. This is done. This is left. Okay. So a particle of 200 grams is moving in a circle of radius 2. The particle is just looping the loop. It is just looping the loop. Okay, just looping the loop का मतलब है VC is equal to under root of RG. Okay, मेरे को confirm करने दो यार. हर बार गड़बड़ हो जाती है. हाँ, वही है. Under root of RG वाला केस है. VC, the topmost point is under root of RG, and the speed of the particle and the tension in the string at the highest point. VC ही पूछा है. VC ही पूछा है, everyone. You have to find out the velocity at c and tension at c. I'm only giving you 30 seconds for this, and your time starts in 3, 2, and 1. Sorry, sir, I don't know why. Relax, Amal. Happens. Sometimes healthy hosting is good for all of you. ये तो हमें याद ही हो गया ना अब तक. By this time you guys remember this, that at the topmost point the tension will be 0. So definitely answer is neither A, it can be B, C or D, and I've given you the formula also. So there was nothing else to do. 2 meter and G value is 10. Root of 20. Root of 20 is 2 root 5. So simplify that, you will get the value. 4, 2 into root 5 का value याद रख लो बच्चों. 2.26 या 2.25 ऐसा कुछ होता है value. Remember, at least 2.2 याद रख लो. So the value will be nearly 4.47 ऐसा कुछ आता है. ठीक है? Okay, Adish, that's great. So we have this, everyone. Now, two more situations, or as in same, everything is same conceptually. Now pay attention, everyone. The two situations that we are going to see in the form of problems are other way of asking the questions from the topic. Okay, so situation number 1, it says that a car is traveling on a smooth road, passing through a curved portion of the road in the form of an arc. So as like a road, there's a road which has an arc like this, and the car is going in this circular track. And obviously there's no tension force now. So can you people tell me what is that force along with mg which will act on the car to make it move in the circular path? It will now be normal force. Okay. Guys, if you find me not visible there in the video, please rejoin the session. You'll be able to see me. Okay. Thank you. Yes, the normal force will be the one. If the mass of the car is given, radius is given, we have to find the normal reaction on the car at the lowest point. So the velocity is given, everything is given. क्या करेंगे? What we will do? We will definitely say that normal is acting towards the center. You see that it is radially inward. Normal is acting radially inward, and mg is acting radially outward. Right, everyone? Should be equal to mv square by r. That's it. तो मुझे n निकालना है. तो क्या हो जाएगा? mg plus mv square by r. So conceptually nothing new. It is only this time instead of tension there is normal force. That's all. Okay. 20 what? 20 what? 25. You said 25. What is 25? Actually, you're talking about answer. 25 kilonewton. Yeah. So this is what it is. After that, there's only maths. So normal will become mv square by r plus mg. Mass of the body is 500 kg. Velocity is 20. Square that value. Radius is 10 meters. Then mass of the body multiplied with g. Simplify करो आंसर आता है 25 किलोमीटर. Easy, right, everyone? अच्छा, एक और चीज बताता हूँ. चलो, इंटरेस्टिंगली एक और चीज बताता हूँ. ये तुम लोगों ने एक्सपीरियंस की होगी शायद. तुम लोगों ने शायद एक्सपीरियंस किया हो ये चीज कभी शायद से. स्पीड ब्रेकर्स. नहीं, स्पीड ब्रेकर एक्सपीरियंस किया है, डेफिनेटली किया है. मुझे पता है स्पीड ब्रेकर तुमने एक्सपीरियंस किया है. पर have you guys ever experienced this, that when your vehicle obviously से बहुत बड़ा होगा, but when your vehicle is taking this turn and if the vehicle comes very fast, then the vehicle actually jumps over it. After taking half of the speed breaker, your vehicle will jump over it, right? That means it loses the contact with the ground over the hump when this goes. There are chances वो जो movies में दिखाते हैं ना, धमाल टाइप की movies में, the vehicle actually takes the aerial route. Why that happens? Let's talk about that. mg is acting, normal is acting, but this time which force is acting towards the center? Which force is acting towards the center this time? V. Sorry, mg, right? So now how will you write the equation? You will say mg minus normal is equal to mv square by r. सबको equation समझ में आती है? Center is downward. Correct? Awesome. Good. So guys, look at the normal force. It is mg minus mv square by r. Is mg a constant force? क्या mg का value constant है, right? So अगर मान लो अगर एक certain velocity, if there is a certain velocity which you cross the speed breaker with, then the normal can become zero. If this value becomes zero, then what do you get? You get v square is equal to rg. You get v square equal to rg, or you get v equal to rg under root. This is the maximum speed. This is the maximum speed with which if you take the vehicle, your vehicle will still be in contact with the ground. Normal will not become zero. By normal becoming zero, what do we mean? The contact between the tires and the ground is gone. The contact between the tires and the ground is gone. Normal becomes zero. So this happens if you take the velocity more than that. If you will take your car with a velocity more than under root rg, r is obviously the radius of that circular portion. Then your vehicle will actually take the radial route for some time. Feel आगे समझ में आ गया? Good. Yes. And now the last question, which I will give as a quiz. I will give this question as a quiz. Okay, everyone. Last question comes as a quiz. Start reading it. इस question में बोला है if there is a rod. This time there is a rod, and you will take this rod here. You will take the rod to the vertical position. Okay. What value will become negative? समर्पिता normal force का value numerically zero से कम नहीं हो सकता. समर्पिता negative हो ही नहीं सकता. Zero ही हो जाएगा. उसके बाद क्या negative? कभी किसी ने किसी को negative force लगाया है? Never. Yes. So guys, question says that on this rod, if you will take the pendulum to be in the vertical position, inverted का मतलब है it was like this. You have actually taken it to the topmost point and released it from there. If you release it from here, थोड़ा सा push देके छोड़ दिया, such that initial velocity you can take it as zero. You can take initial velocity to be zero. You have to find the tension in the rod at the lowest point of the trajectory. If this is the highest point and this is the lowest point, everyone, you have to find the tension in the rod at position A. Only suggestion that I have is energy at C will be equal to energy at A, and length of the rod will be treated as the radius of the circular path. Okay, tension in the rod means the tension force which is acting in the rod. Rod is like a strong rod. Rod is like a strong, very powerful rope. You have to talk it like that. Okay, radius is equal to the length of the rod. Okay. Setting up the quiz. Set तो करने दो यार, तुम लोग सवाल ही पूछते होगे, हाँ, solve करते होगे. So giving you guys 60 seconds and your time starts in 3, 2, and 1. Come on, people. Initial velocity at C has to be taken as 0, and at B you will have to talk about the velocity. You will have to use the law of conservation of energy. And at A you will have to find out the tension by using the equation of centripetal force. Centripetal force की equation लिखनी पड़ेगी A पे. Everyone. Okay, time's up, guys. Time's up. Okay, the correct answer is option B. और बहुत आसान था. पहले एनर्जी कंजर्वेशन लगाना था. तो टोटल हाइट इज इक्वल टू 2L. तो एट द हाईएस्ट पॉइंट ओनली पोटेंशियल एनर्जी. मैंने बोला था पोटेंशियल एनर्जी है, जीरो वेलोसिटी लेना है, राइट एवरीवन. एंड एट the lowest point, no potential energy, only kinetic energy. From here, velocity comes out to be under root 4gl. You already know this, by the way. At the bottommost point, velocity will come out to be under root 4gl if the topmost point has zero velocity. And then at the lowest point, this is going to be tension, downward is going to be mg, and this is velocity. Okay, so T minus mg equal to mv square by r. This you said already. Yes, I have. So tension comes out to be mg plus mv square by r. Simplify करो, मैं mg आ जाता है. कुछ लोगों को शायद याद भी रहा हो. We have already found this tension value, right? Cool. Okay, well done, everyone. I hope you guys enjoyed the power pack session of vertical circular motion. One of the most important topics of circular motion is vertical circular motion, and very useful, very, very useful. Okay. Sir, are you using any mic? Good sound? No, I'm not using any mic. It's the same, my laptop. Okay. And as always, for all of you, thank you. Sir, is CM completed? Circular motion completed today. Okay. Well done, everybody. Well done. नहीं बस हर चीज आज एक ही दिन में नहीं मिलती. Good things come in small packages. Thank you, Samarthika. Thank you, sir. Can we leave? Yes. Class teachers also can leave. Those students who want to leave can also leave, because this is officially the end of chapter, end of the session also. Okay. Welcome guys. Welcome. Next chapter I think will be center of mass and collision. We'll start with center of mass and collision. I think. Sir, एक बात बोलूँ. अरे वीडियो ऑडियो में बोलो मेरे भाई. तो तुम्हारे पास माइक्रोफोन ही नहीं है. Sir, talk about some news. India might win the Lord's Test match in some time. That's news, right? Okay. अरे वंश कुछ लोग अनम्यूट होना चाहते हैं. Yes, Adia. Good evening. Tell me. You said that your approach was right, but still you didn't get to the answers correctly. Did you try to find the reasons? Is it because of silly calculation mistakes or some other reason? This somehow is the part which I would require a little more detailing on. Then possibly there are two reasons for it. One, maybe you are not solving the level of questions which actually are above, the preliminary level questions. Maybe you are still only in the preliminary zone of problem solving. You have to actually take a notch above. When you're practicing, you have to actually raise your level of problem solving. Okay. Second one is when you are applying the concept, when you're solving the question. Maybe you're solving the questions also, the questions while practicing. But then maybe you're not actually while practicing also. Maybe you are not going there also in the right direction. Do you look back at the solution when you're solving it for the first time? When by practicing, look back as in look at the solution, look at the notes. Even after the first attempt, you do this. That is where the mistake is. That is where the mistake is, Savya. Once you do not get the answer right, you should not look for the solutions. You should try this one more time to see what happened. Was there my approach wrong? Because you don't get to find your own mistakes by organically trying other approach and figuring out what went wrong in the first approach. So that is where you are developing the what should I say, the maturity of JEE preparation, which is basically nobody else needed to tell you what is wrong with the approach. You realizing whether this approach is right or not about a given question. That comes by practice. And that is why Sadia and everyone else, I got your point, and that is why for everyone, not just you, it is actually acceptable to solve lesser problems, but solve them, I would say, quality problems, and really struggling through the problem solving is more important. I have said this a number of times. Struggling through the problem solving is what precisely it is. When you do not get the answer in the first attempt, do not just look for the solutions easily. Let yourself go through that pain, the process of struggle, of thinking more, of thinking something else, trying a different approach. That is what is important. That is what is required. I do not know whether that will be possible as per the availability of the time is the real question here. Because usually exercise 1 and 2 are so lengthy in general that many students don't find time to even go to third exercise. Okay, so if you get time, it's fine. If you get time, it's fine. Otherwise, exercise 1 and 2 are quite good, I would say. For the first round of problem solving when we do, it's absolutely fine. Okay, so try the solution that I've given you. Okay, okay, bye. Sir, please take one session on graphs in kinematics. Hai? I have already. Pila Monish. Yes, Monish. Not getting your question. What's your doubt? You said a question in the chat. Velocity of a particle is given. The component of velocity parallel to a vector will be. Oh yeah. So I'll just give you the logic of how this works. Okay. So say you have a velocity vector, and say there is this another vector which is in this direction. Okay. So the question is asking you to find out the component of the velocity parallel to this vector. That means if you have this vector A, question is asking you to find out the component of this vector which is along this direction. Okay. How do we do that? Say we have both the vectors A and B. You will find out the value of A. Just think of it this way. If this would have been x-axis, then what would I say the component is? I would say A cos theta, right? And the direction is I cap, right? So forget about I cap part. A cos theta is what I'm interested in finding. Okay. But not always the question will say that the component that you're finding is on x-axis. That could be any random direction. So maybe this is vector B, and instead of I cap, now I need the direction B cap. Means a unit vector which is along the direction of B. Then also my purpose is solved. Getting my point, Manish? So how do we do this? We find out the value of dot product of A and B, which comes out to be A into B into cos of theta. You know this, right? And from here, I just want to write it so smartly that I will say it is A cos theta, which will be equal to A dot B divided by B. Either they would have done this in solution. They would have done this in solution, or they might have written something else also. What is vector B divided by its own magnitude? It's unit vector. It's unit vector. So either by this or by this, you can solve this. I would recommend the first one. You can find out A dot B easily, and you can divide it by the magnitude of B. You will get it. Okay. No sir, we did not have graph session. हमने ग्राफ्स नहीं पढ़े क्या काइनेमैटिक्स में भी? हाँ, मतलब हर एक टाइप ऑफ मोशन के ग्राफ्स देखे थे ना हमने, बल्कि हमने उससे डेरिवेशन भी किए थे इक्वेशंस ऑफ मोशन के. सो वेयर इज दिस गाय? Vishesh, we have done the graphs. We have done derivations of equation of motion from graph. Anyway, yes, Vihan, tell me. मैं एकदम बढ़िया यार, better than ever. अभी नहीं यार, एकदम भूखा है. No worries. What happened in January training? Okay, ठीक है, तो कल बाद में लेते हैं, पहले सवाल पूछो. Not every 3 approaches will be there, but multiple approaches basically. Probably one of them again. जो तुमने प्रैक्टिस किया था. So did you not revise these questions? फिर क्यों भूल गए? वन ऑफ अ काइंड सिचुएशन है. वन ऑफ अ काइंड सिचुएशन हो जाती है, बहुत दिमाग से स्लिप हो गया एग्जाम में, एग्जैक्टली वही चीज याद नहीं आ रही है, बहुत होता है यार, यहाँ पे इट इज राइट ऑन द टिप ऑफ द टंग बट नहीं आ रहा है. Happens, sometimes happens. That's fine. You don't consider it as a wrong. I don't consider it as a very bad score. I do not obviously certainly say कि वो बहुत awesome score है, पर वो acceptable score है. वो acceptable इसलिए because you guys are still learning. और इस learning process में मेरा first belief है कि अपना selection secure करने के लिए JEE के पेपर से independent होना चाहिए हमें. By that I mean, you know that generally for qualifying from JEE Main to JEE Advanced, out of 300 if I get a score of more than 100, I will definitely qualify for JEE Advanced. On a safer side, let's call it 120. But definitely above 100, people who score, they get 97% plus. अरे यार, हमारे पेपर तो 10 लाख स्टूडेंट JEE का एग्जाम लिखते हैं, उसमें से 5 से 6 लाख स्टूडेंट्स को पता भी होगा कि JEE क्या है. Yes, actually, people just go for 12 standard because somebody in their class is preparing for the exam. They also fill the form. That's how I filled it on the first place in 12 standard. मुझे नहीं पता था JEE क्या है, उसमें क्या करना होता है, what does it give you. With 12 I appeared for it because some of my friends were appearing for that examination. So that year I had no idea कि मुझे क्या expect करना चाहिए JEE से. So people just go. हाँ, but JEE भी होता था, ये ट्रिपल भी होता था, दोनों एग्जाम भर दिए, दे दिए. हाँ, तो obviously नहीं हुआ सिलेक्शन obviously. Might be drop exactly. After that I realized कि यार ये होता है क्या पढ़ना था तो ठीक है चलो ड्रॉप ले लेते हैं. That's how it was. So that is not maybe now the awareness has increased, but the seriousness still is the same. अब लोगों को पता है कि जेई क्या है और देना चाहिए, लेकिन seriousness नहीं आती है सब में. Exactly. बहुत कम लोग हैं जो सीरियस है उस चीज को लेके. कट ऑफ टोटली द ट्रेंड ऑफ द स्कोर्स यार, नथिंग एल्स. कट ऑफ ओनली द ट्रेंड कि कितने बच्चे हैं जो एक सर्टेन स्कोर से ऊपर हैं. दैट इज व्हाट इज कॉलिंग कट ऑफ. कट ऑफ क्या है? अगर मुझे टोटल 2.5 लाख स्टूडेंट्स को जेई एडवांस एग्जाम देने के लिए परमिट करना है, तो जितने स्टूडेंट्स टॉप 2.5 लाख में आ गए, व्हाटएवर इज द स्कोर ऑफ द 2.5 लाख स्टूडेंट्स, उसमें आखिरी स्टूडेंट का पूरा वही कट ऑफ है. तो पिछले 20 साल का ट्रेंड तो यही बोलता है, एटलीस्ट 10 साल का ट्रेंड तो यही बोलता है जब से जेई मेन आया है. स्कोर इज नेवर मोर देन 1/3 ऑफ द हाईएस्ट स्कोर. मतलब 360 में से 120 भी कभी नहीं गया कट ऑफ, कभी नहीं गया. तो बहुत सारे स्टूडेंट्स जो हैं उनका स्कोर क्लैश भी होता है. बहुत सारे मतलब हजारों में स्टूडेंट्स होंगे, लाखों में स्टूडेंट्स हो सकते हैं जिनका स्कोर एक्चुअली सेम हो. तो फिर उसके बाद में डिसाइडिंग फैक्टर्स होते हैं, और डेफिनेटली बहुत सारे स्टूडेंट्स हैं जिनका स्कोर सेम आ सकता है, तो उन सबको रैंक सेम दी जाती है या उन सबको सेम परसेंटाइल पे देखा जाता है. इसलिए तो लाइक दिस टाइम 5 स्टूडेंट्स गॉट 100%. Calculating a percentage is not in your hand. Calculating percentage is the job of NTA. They have the scores of everyone. You can calculate your percentage, you cannot calculate your percentage. So you have to first always become independent of the JEE pattern. मतलब कितना भी difficult पेपर है, कितना भी easy पेपर है, तुम हर बार 120 प्लस लाओगे, ये वाले ट्रेंड के बारे में पहले सोचना है. So if you become independent of that, then in itself you have the confidence कि मैं कोई सा भी JEE का पेपर है, कितना भी difficult है, कितना भी easy है, मेरा सिलेक्शन होगा. And that is more important, right? Hmm. Hmm. Now you know. Okay. Hmm. Try to solve questions. Try to solve questions now. सब लोग मुझे questions करने की कोशिश करो. फिर उसके बाद में कभी उसको रिप्लाई लिखना बंद. ठीक है. Try something called as Pomodoro technique. That's it. That's it. और strong belief रखना. क्या है ये distractions? कहाँ से आते हैं? Uh, no, you can actually have to go to the root cause of the situation. Okay. थिंक अबाउट इट कि क्या गड़बड़ हो रहा है, क्यों हो रहा है ये सिचुएशन, व्हाई इज इट. अगर कोई ऐसी चीज है जो तुम्हारा टाइम एक्सपेक्ट कर रही है, तो एक बार उसको टाइम दे दो, उसे सॉर्ट आउट कर दो, ताकि उसको टेंशन ना दे बार बार दिमाग में. ऐसा कुछ करो, है ना. ट्राई टू आंसर द रूट कॉज ऑफ द प्रॉब्लम, सॉर्ट इट आउट एंड देन गेट बैक टू स्टडीज. ठीक है. चलो चलो, और ये वन म्यूट होना है. ओके. हां, कितने लोग म्यूट होना चाहते हैं आज? सबको म्यूट होना है. ये सिद्धार्थ हां, कीप इट क्रिस्प. 27 ये है यार. 27 तो ये वाला डेरिवेशन यहाँ किया है. तो कौन सा, उसमें भी दो तरह के डेरिवेशन है, दो तरह के डेरिवेशन है. ये वाला ए और बी के बीच में होगा. तो बताया तो ये देखो, एनर्जी एट ए इक्वल टू एनर्जी एट पी. ठीक है. पी के लिए तुम बोलो एकदम मिडिल में, तो थीटा कितना होना चाहिए. तो बस यहाँ पे 45 डिग्री पुट करो, हाइट मिल जाएगा, उसे यहाँ पुट करो तो वेलोसिटी मिल जाएगी. बस दो चीजें याद रखो वर्टिकल सर्कुलर मोशन में, एक सेंट्रीपेटल फोर्स कैसे लिखते हैं, दूसरा लॉ ऑफ कंजर्वेशन ऑफ एनर्जी कैसे लगाते हैं. दैट्स इट. सब कुछ सॉल्व हो जाएगा इन दो चीजों से, वर्टिकल सर्कुलर मोशन. ओके. खुद को वापस नहीं वाला सेशन. ओके, वेरी गुड. ओके, बाय बाय. राजकुमार यार रुको जरा, अमन आदित्य से बात करने दो. हाँ अमन, स्पीड ब्रेकर वाला जिसमें मैंने बताया था कि मिनिमम मैक्सिमम वेलोसिटी जिससे तुम क्रॉस कर सकते हो, ये वाला. ये एमवी स्क्वायर बाय आर इधर आ गया, एन वहां चला गया, तो इक्वेशन बन गई एमजी माइनस एमवी स्क्वायर बाय आर. ठीक है. मैं कब बोलूंगा कि मेरा व्हीकल जो है वो हवा में चला गया, जब उसका नॉर्मल कोड जीरो हो जाएगा, उसको जीरो से इक्वेट कर दिया, और फिर पता लगाया कि वेलोसिटी कितनी होगी जिस पे ऐसा होगा, या जिसके बाद ऐसा हो जाएगा, तो वो वेलोसिटी आती है अंडर रूट आरजी. तो इससे ज्यादा कोई भी वेलोसिटी के साथ में अगर तुम गए और उस पे जाने की कोशिश करोगे, तो तुम्हारा व्हीकल थोड़ी देर के बाद में कॉन्टैक्ट छोड़ देगा. ऑब्वियसली सिलेबस बढ़ रहा है, कांसेप्ट्स की कॉम्प्लेक्सिटी बढ़ रही है, मल्टीपल कांसेप्ट्स इन्वॉल्व वाले क्वेश्चन आना शुरू हो जाएंगे. सभी का स्कोर नीचे जाता है, सिर्फ तुम नहीं हो, सबका नीचे जाता है. मैं पहले भी बोला था कि कुछ लोग हैं, आई कैन से दे आर गॉड गिफ्टेड आल्सो. कुछ कुछ लोग सच में होते हैं गॉड गिफ्टेड होते हैं, मैं भी उनमें से नहीं हूं. ठीक है. दूसरी बात, कुछ ऐसे भी होते हैं जिन्होंने पहले से पढ़ना शुरू कर दिया था बिफोर इवन देयर 11th स्टैंडर्ड, तो ये उसका बेनिफिट भी मिलता है, पर ये माइलेज कुछ टाइम तक के लिए मिलता है उनको भी. मे बी बाय दिवाली और बियॉन्ड दिवाली यू विल सी दैट की सबकी हालत एक जैसी हो, एक्सेप्ट जो एक्चुअली गॉड गिफ्टेड है. ठीक है. एज आई सेड अर्लियर आल्सो, अपने आप को सिर्फ अपने आप से कंपेयर करो, एटलीस्ट फॉर 11th स्टैंडर्ड. यार ये जो ना मोटिवेशन, ये एक्चुअली ना ये इट्स लाइक फीलिंग फ्रेश. हम लोग हर रोज सुबह उठते हैं ना, तो एक्जैक्टली वही फ्रेशनेस के साथ नहीं उठते, इसीलिए हमें डेली नहाना पड़ता है. तो मोटिवेशन के साथ भी कुछ ऐसा है कि हमें डेली अपने आप को डोज देना चाहिए. तो वो किस फॉर्म में मिलता है वो अलग अलग होता है. किसी दिन कोई गाना सुन के मोटिवेशन आ जाता है, किसी दिन ओलंपिक्स में गोल्ड मेडल आ गया ये देख के मोटिवेशन आ जाता है, कभी हमने कोई अच्छी मूवी देख ली तो मोटिवेशन आ जाता है, कभी किसी टीचर का कोई सेशन अटेंड कर लिया तो मोटिवेशन आ जाता है. पर जब भी ऐसा डिमोटिवेटेड फील हो, तो अपने आप को उस सिचुएशन से मेंटली बाहर निकालने के लिए कुछ करो. और अगर तुमने इन 2 सालों में ये चीज पहचान ली कि व्हेन यू आर एक्चुअली फीलिंग डिमोटिवेटेड, व्हाट इज इट, दैट विल ऑलवेज ब्रिंग यू बैक ऑन ट्रैक. अगर वो भी पता लगा लिया तो अपने आप में बहुत बड़ा एक ब्रेक थ्रू है. ओके. तो डेफिनेटली मोटिवेशन चाहिए और उसे बार-बार उसका सोर्स मिलते रहना चाहिए, उसका डोज मिलते रहना चाहिए। ठीक है। यस, यस। गुड, गुड, गुड। चलो, ओके, बाय, गुड नाइट। समर्पिता, योर नंबर आफ्टर राजकुमार। यस, राजकुमार। हाँ, पोजीशन और डिस्प्लेसमेंट का मतलब ये कहाँ से आ रहा है क्वेश्चन? तो ये तो मैं बहुत बार बता चुका हूँ ना कि इंटीग्रेशन ऑफ वीडीटी से डिस्प्लेसमेंट मिलता है। क्या दिया है? और कब पूछा है डिस्प्लेसमेंट, कब पूछा है पोजीशन, ऑफ व्हाट टाइम? तरीका बता दूँ? जैसे मान लो क्वेश्चन ने पूछा कि t इक्वल टू 1 पे पोजीशन पता लगाओ और t इक्वल टू 3 पे पोजीशन पता लगाओ। तो t का वैल्यू पुट कर दो, तो उससे पोजीशन मिल जाएगी। ये एक्स कोऑर्डिनेट होता है, वही तो पोजीशन होती है बॉडी की। ठीक है? फिर t इक्वल टू, तो पहले dx/dt कर दिया, उसको 0 से पुट कर दिया, तो एक टाइम की वैल्यू आएगी। उस टाइम को 5 सेकंड में इक्वेशन में पुट कर दो, पोजीशन मिल जाएगी। नहीं, सेम नहीं होगा, क्योंकि जब तुम t इक्वल टू 0 पुट करोगे तो 40 आएगा। तो उसका मतलब ये हुआ कि इनिशियली t इक्वल टू 0 पे बॉडी की लोकेशन 40 है, t इक्वल टू 5 पे बॉडी की लोकेशन क्या है वो पता लगाना, इन दोनों के बीच का जो डिफरेंस है वो है डिस्प्लेसमेंट। ऐसा सोचो ना, तुम t इक्वल टू 0 पे यहाँ थे, t इक्वल टू 5 पे यहाँ आ गए, तो इन दोनों के बीच का गैप क्या होगा? यहाँ का x कोऑर्डिनेट और यहाँ का x कोऑर्डिनेट का डिफरेंस। थोड़ा तो विजुअलाइज करना पड़ेगा ना मित्र, अब तो आएगा आंसर। ठीक है? अगर इस चक्कर का नहीं है तो अभी मैं टाइम नहीं दिखाऊंगा। ओके, नहीं। हाँ, समझ में, वेयर आर यू? लास्ट क्वेश्चन, व्हाट इज द वैल्यू ऑफ एल? एक मिनट, है ना? वैल्यू ऑफ एल के बिना आंसर आ जाएगा, है ना? वैल्यू ऑफ एल कैंसिल हो जाएगा, कोई भी वैल्यू ऑफ एल के लिए आंसर विल बी 5 mg, है ना? यस, समझ रहा हूँ। यस, यू आर, टेल मी। तो जल्दी जल्दी पूछना। आज का? ये सही, ये वाला, ये वाला, ये वाला, ये भी नहीं। हाँ, नॉन एक्सेलरेटिंग नहीं, नॉन यूनिफॉर्म है। वेलोसिटी कांस्टेंट नहीं रहेगी बॉडी की मूव करते समय। नॉन यूनिफॉर्म है, और नॉन यूनिफॉर्म भी एक्सेलरेटेड भी है। बेसिकली नॉन यूनिफॉर्म सर्कुलर मोशन है, ज़्यादा अच्छा तरीका वो है समझने का। नहीं, करेक्ट है ना? इफ यू इफ यू वांट टू स्पीक, यू हैव टू वेट। अ लॉट ऑफ पीपल वांट टू टॉक टुडे, तो तुम लोग रुक सकते हो तो रुक जाओ, एक-एक करके मैं म्यूट कर रहा हूँ। हाँ, यू सेड क्वेश्चन स्लाइड नंबर 14, वी आर ऑन स्लाइड नंबर 14, वी आर ऑन स्लाइड नंबर 14। हाँ, यही 14 है। तो एक्चुअली सिचुएशन बहुत कॉम्प्लिकेटेड होगी, जो हमारे वर्टिकल सर्कुलर मोशन के स्कोप ऑफ अंडरस्टैंडिंग के बाहर है। बहुत कॉम्प्लिकेटेड मोशन, पहली बात तो मोशन ही सर्कुलर नहीं होगा। हाँ, वो मोशन कुछ अलग ही ट्रैजेक्टरी होगी जिसको कोई नाम नहीं दे सकेंगे। मतलब ऐसा होगा कि बॉडी जब सर्कल में है तो वो मतलब ऐसे ऑसिलेट भी कर रही है और ऐसे घूम भी रही है, तो बेसिकली ऐसा ऐसा कुछ मोशन होगा उसका एक्चुअली। ये होगा बॉडी का मोशन। हाँ, मतलब वेव भी प्रॉपर वेव बनेगी नहीं बनेगी वो भी हम लोग क्लियरली नहीं बोल सकते, बनेगी तो भी हमारी प्रॉब्लम है वैसा। यही स्लाइड थोड़ी है, जो है क्या? टेंशन ही जीरो होता है, टेंशन जीरो होता है। जिसमें टेंशन जीरो होता है वो वाला स्लाइड ना, ये वाला पार्ट। वेट नहीं जीरो होता, टेंशन जीरो होता है उस टाइम पे। ये जो टॉप मोस्ट पॉइंट है ना, यहाँ पे टेंशन को जीरो किया था, और एमजी जो है वो एमवी स्क्वायर बाय आर के बराबर हो गया था। सेकंड केस में एमजी कहीं जीरो नहीं होगा, एमजी जीरो होने के लिए ग्रेविटी को जीरो होना पड़ेगा, कहीं भी एमजी जीरो नहीं है। ये जो सिचुएशन थी, मैंने बोला था यहाँ पे टीसी प्लस एमजी इक्वल टू जीरो आएगा, इसका मतलब होगा टीसी इक्वल टू माइनस एमजी। बट इसकी अंडरस्टैंडिंग ये है कि बॉडी के ऊपर लगने वाला टेंशन बहुत पहले जीरो हो चुका है, एमजी है जो कि बॉडी को आगे लेके आ रहा है, या फिर एमजी का कंपोनेंट उसको आगे लेके आ रहा है। मोमेंटम ही है जो आगे ला रहा है, लेकिन सेंट्रीपिटल फोर्स की तरह एमजी कॉस थीटा बिहेव कर रहा है, दैट्स व्हाट आई सेड। हाँ, थंडर थंडर करके एक राइड है असल वर्ल्ड में, जो कि बिल्कुल एक रॉड है, बहुत बड़ी सी रॉड है, और वो रॉड ऐसे रहती है जिसमें लोग यहाँ होते हैं, और ये ऐसे वर्टिकली ऊपर चली जाती है। मतलब ऐसे तो घूमती रहती है, लेकिन एक टाइम ऐसा भी आता है जब वो ऊपर जाके रोक देते हैं उसको। नहीं, वो रॉड है ना, वो स्प्रिंग थोड़ी है, वो स्प्रिंग नहीं है। हाँ, तो डेफिनेटली बहुत स्केरी, बहुत रिस्की है, और वही थ्रिल होता है बहुत से लोगों के लिए, लेकिन वो जो भी सीट पे बैठे होते हैं वहाँ पे बहुत अच्छे से उनको पकड़ के रखा जाता है, इसीलिए गिरते नहीं है, वरना टेक्निकली गिर जाएंगे। यही तो पॉइंट अभी इसमें बात कर रहे थे। हाँ, मैंने बताया भी था कि वो पॉइंट निकाल, हाँ तुमने बोला था एक बार। तो पॉइंट पी निकालने के लिए हमें ये पता होना चाहिए कि हमने कितनी वेलोसिटी के साथ में थ्रो किया बॉडी को ए से, और हमने एक्चुअली पता भी लगाया था आगे एक सिचुएशन में, पहला जो तुम लोगों ने क्विज किया था ना वो यही था। पहला तो यही था कि बी पे बॉडी जा रही है, उसको जो वेलोसिटी दी है वो अंडर रूट ऑफ 2gl से भी कम है, तो बॉडी बी तक नहीं पहुंचेगी, पी पे जाके उसका एक्चुअली ये जीरो हो जाएगा, क्या बोलते हैं, काइनेटिक एनर्जी जीरो हो जाएगी। तो अगर हम चाहते हैं टेंशन जीरो हो जाए, तो हमें ये मालूम होना चाहिए कि हमने कितनी वेलोसिटी के साथ उसको प्रोजेक्ट किया है, तो हम निकालेंगे लोकेशन आराम से। और सिर्फ और सिर्फ दो ही कॉन्सेप्ट यूज होते हैं हर एक क्वेश्चन, हर एक सिनेरियो में, एक सेंटीमीटर फोर्स की इक्वेशन एमवी स्क्वायर आर, और दूसरी लॉ ऑफ कंजर्वेशन ऑफ एनर्जी। ठीक है सर? लूपिंग द लूप का मतलब है सर्कल में घूमना पूरा। 25, हाँ, पैराबोलिक वाला पॉइंट। हाँ अगर जीरो होगी तो गिर जाएगा, बिल्कुल वो ऐसे ही रहेगा नीचे डायरेक्ट, गिरने के बाद ऑसिलेट करेगा, बिल्कुल करेगा, क्योंकि नीचे गिरने के बाद में जब उसकी सिचुएशन देखी जाएगी तो उसकी वेलोसिटी डाउनवर्ड होगी, यहाँ पे जाकर के जो वेलोसिटी है उसका एक कंपोनेंट है जो उसको डाउनवर्ड लेके आएगा, या ऐसा बोलो कि डाउनवर्ड एनजी साइन थीटा भी है, इवन इफ इट स्टॉप्स बाय कमिंग टू द बॉटम मोस्ट पॉइंट, बॉटम मोस्ट सॉरी, यहाँ आके जब वो रुकेगा ऐसे सिचुएशन में, तुम सी की बात कर रहे हो, नहीं नहीं सी से अगर नीचे गिरा तो ऑसिलेट नहीं करेगा, मतलब ऐसा सोच सकते हो कि थोड़ी देर के लिए वो अप एंड डाउन वाला ऑसिलेशन करेगा, थोड़ी देर के लिए, और वो भी इतना थोड़ी देर होगा कि फ्रैक्शन ऑफ सेकंड्स में ही वो एनर्जी बहुत फटाक से लूज हो जाएगी, बहुत जल्दी लूज हो जाएगी वो एनर्जी। अगर तुम बुरा ना मानो तो जितने लोग एकेडमिक डाउट से पहले मैं आंसर कर दूं ठीक है, ओके फिर मैं म्यूट करता हूं, ओके सर वॉइस फ्रॉम वर्टिकल अपवर्ड विद द फॉलोइंग ग्राफ रिप्रेजेंट वेलोसिटी टाइम ग्राफ विशेष आई हैव सेड दिस इन नंबर ऑफ टाइम्स, डाउट्स दैट आई टेक आफ्टर द क्लास शुड बी फ्रॉम द गिवन सेशन, इफ यू हैव डाउट अदर देन दिस प्लीज यूज द डाउट ऐप, ओके विशेष हाँ बता रही आवाज आ पाई तुम्हारी, तो क्या बोल रही हो वो नहीं सुना, तुम लोग डाउट आप पे क्यों नहीं पूछते हो, बोलो। Gravers are dropped on a conveyor belt at the rate of 0.5 kg per second. The extra force required in Newton to keep the belt moving at 2 meter per second. और क्या इन्फॉर्मेशन दी है, kg per second और वेलोसिटी, अरे यार फोर्स क्या होता है, रेट ऑफ चेंज ऑफ लीनियर मोमेंटम, राइट, और मोमेंटम को हम क्या लिख सकते हैं, मास इनटू वेलोसिटी, अब यहाँ पे वेलोसिटी कांस्टेंट रखनी है, मास कंटीन्यूअसली गिरता जा रहा है, इंक्रीज होता जा रहा है, तो v डेल्टा m बाय डेल्टा t या dm बाय dt, तो v कितना दिया है 2, dm बाय dt कितना दिया है हाफ, आंसर शुड बी 1 न्यूटन, दैट्स ऑल, ओके ऐसा ऐसा वाला है क्या, यहाँ पे टेबल है ऐसा, ओके और यहाँ पे मास ऐसे, एक मिनट ये तो स्टैंडर्ड है, ओके ये आ गया, फिर यहाँ आ गया, यहाँ इसमें यहाँ मास है, यहाँ पे भी मास है, यहाँ पे भी मास है, क्या पूछा है इसमें, 2 मिनट रुक जाओ विशेष, आफ्टर दिस आई विल अनम्यूट यू, मेक श्योर यू हैव योर माइक वर्किंग, यस बना ली, three masses 1 6 and 3 are connected each other with thread and are placed on a smooth table if g is this magnitude of acceleration of 6 kg block, ये 1 है, ये 6 है और ये 3 राइट, तो यहाँ पे मान लो कि टेंशन T1 है और यहाँ पे मान लो कि टेंशन T2 है, ठीक है, कैसे बोला या ऐसे बोला, हाँ ठीक है, तो देख के लग रहा है कि 3 kg नीचे आना चाहिए, 1 kg ऊपर जाना चाहिए और एक्सेलरेशन सेम होगा बिकॉज़ ऑफ द कंस्ट्रेंट मोशन, ठीक है, तो इसकी इक्वेशन लिखो, इसकी इक्वेशन लिखो और इसकी इक्वेशन लिखो, तो जब 1 के लिए लिखूंगा, सॉरी पहले 3 के लिए लिख लेते हैं, तो 3 के लिए आएगा 3g द वेट एक्टिंग डाउनवर्ड माइनस टेंशन T2 एक्टिंग अपवर्ड इक्वल टू 3a, ठीक है, 1 के लिए लिखूंगा तो इक्वेशन आएगी T1 माइनस 1g इक्वल टू 1a, ये इसकी इक्वेशन हो गई, अब देख रहे हो 2 इक्वेशन है और 2 से ज्यादा अननोन है, 3 अननोन है, तो अब 6 के लिए भी लिखना पड़ेगा, अगर 3 नीचे आ रहा है 1 ऊपर आ रहा है तो 6 राइट जाएगा या लेफ्ट जाएगा, राइट, दैट मींस T2 इज ग्रेटर देन T1, तो लिखना पड़ेगा T2 माइनस T1 इक्वल टू 6a, बस इस इक्वेशन में T1 से कैंसिल, T2 से कैंसिल, सिंपलीफाई करो, a आ जाएगा, ओके ओके, तो लेकिन विशेष बोलो, ग्राफ वाला बोलो बोलो बोलो, व्हाट इज व्हाट, हाँ ये ग्राफ है, ऊपर सो गया, ये ग्राफ है, अबे यार जब हम बॉडी को ऊपर देखते हैं तो उसकी वेलोसिटी पॉजिटिव या नेगेटिव, पॉजिटिव, तो डेफिनेटली ग्राफ पॉजिटिव वाई एक्सिस से शुरू होगा, ठीक है, जब बॉडी एकदम टॉप मोस्ट पॉइंट पे पहुंचेगी, टॉप मोस्ट पॉइंट पे, तब उसकी वेलोसिटी कितनी होगी, 0, तो यहाँ 0 हो गया, अब बॉडी नीचे आना शुरू होगी तो बॉडी की वेलोसिटी पॉजिटिव या नेगेटिव, नेगेटिव होगी, तो नेगेटिव आना शुरू होगी, अब सिर्फ डाउट ये है कि सर स्ट्रेट लाइन ग्राफ होगा क्या नहीं होगा, वो है v इक्वल टू u प्लस ct व्हिच इज y इक्वल टू mx प्लस c, दैट्स इट, ठीक है, तो थोड़ा सा मैथ्स को फिजिक्स में लेके आओ, टेस्ट बढ़ाओ तो हो जाएगा, ठीक है, ओके सर हाउ टू विजुअलाइज दैट कन्वेयर बेल्ट क्वेश्चन, एक्चुअली श्वेता जस्ट इमेजिन, श्वेता हैव यू एवर बीन ऑन ट्रेडमिल, हैव यू एवर बीन ऑन अ ट्रेडमिल, यस, नहीं नहीं श्वेता की बात कर रहा हूँ, Shweta, when we try to run on the treadmill, we actually put our weight on the treadmill. So treadmill has to actually pull itself even by compensating the force that we apply. So it's the force of friction which increases on the belt because of us, because of our weight, the friction force increases. So the motor has to actually give more energy, more work in order to make the treadmill move. Okay, you can think of it this way also, that treadmill is moving. If you try to press the treadmill by your own hands, it will become difficult for the treadmill to move. In fact, if you press it very strongly, or if you put a very heavy weight, the treadmill will not even rotate because the motor will not be able to deliver that much amount of power that it requires. Okay, अंश रुको बच्चा, सर इफ बॉडी स्टार्ट्स टू ऑसिलेट इन सर्कुलर मोशन देन द बॉडी कंटिन्यूज टू ऑसिलेट अनलेस एन एक्सटर्नल फोर्स एक्ट्स, फिर अभी ऑसिलेशन पढ़ा नहीं है, जब पढ़ेंगे तो आंसर आ जाएगा, अभी ऑसिलेशन के बारे में कोई कमेंट नहीं कर रहा हूं, ओके, है ना से सर प्लीज आंसर माय क्वेश्चन एवरी, इवन स्टडीिंग विद क्वेश्चन टेक्स अ लॉट ऑफ टाइम सर, कभी बहुत सारे कांसेप्ट आते हैं इन तत्व व्हिच आर नॉट अवेयर ऑफ सर, इवन सॉल्विंग लेस क्वेश्चंस टेक टाइम एंड लेस क्वेश्चंस आर ऑन माय हेड लाइक बैकलॉग, तो डेफिनेटली सॉल्विंग लेस क्वेश्चन टेक्स टाइम एंड दैट इज व्हाई आई हैव सेड ट्राई अ क्वेश्चन 3 टाइम्स, आफ्टर दैट लीव दैट क्वेश्चन, मूव टू द नेक्स्ट क्वेश्चन, बट डेफिनेटली यू हैव टू कीप अ ट्रैक ऑफ द बैकलॉग एंड कीप ऑन मेकिंग श्योर दैट यू आर गेटिंग दैट बैकलॉग क्लियर्ड, ओके, किधर गया वो अनम्यूट करने के लिए, हां अंश बोलो बच्चा, तो दैट सिंपली मींस कि तुम ये कोशिश करते हो कि तुमने कोई क्वेश्चन सॉल्व किया था तो उसका मेथड याद आना चाहिए तुम्हें, बट एक्चुअली ऐसे तुम 12 स्टैंडर्ड कंप्लीट होते हो तो कितने क्वेश्चन करके याद रख पाओगे? हर क्वेश्चन जेई में हर क्वेश्चन अच्छा हर क्वेश्चन अपने आप में कॉन्सेप्ट होता है। इसीलिए मैं हर बार बोलता हूँ कि फिजिक्स में जब क्वेश्चन आता है तो उसको विजुअलाइज करने की कोशिश करनी चाहिए कि ये क्वेश्चन क्या बोलना चाहता है और इसमें पॉसिबली क्या चैप्टर लग रहा है और उस चैप्टर का कौन सा कॉन्सेप्ट पॉसिबली लग सकता है, ये फिगर आउट खुद से करने की कोशिश करना है। सही अप्रोच नहीं है, वो अच्छी अप्रोच नहीं है। शुरू में काम करती होगी, शुरू में काम कर भी सकती है अभी, लेकिन जैसे जैसे कॉन्सेप्ट बढ़ते जाएंगे, जैसे जैसे चैप्टर्स बढ़ते जाएंगे, वैसे वैसे चीजें और मुश्किल होती जाएंगी, है ना? आई आंसर योर क्वेश्चन, लूपिंग द लूप का मतलब है सर्कल में घूमना सक्सेसफुली, है ना? ओके अंश, ट्राई टू अप्रोच द क्वेश्चन विद कूल माइंड, यही बोलूंगा। ये तत्व में नहीं, ये जनरली फिजिक्स में होता है, इसीलिए बहुत बार जो क्वेश्चन मल्टीपल कॉन्सेप्ट वाले होते हैं मैं बोल देता हूँ कि उसे अभी मत करो, क्योंकि आगे आएगा वो चैप्टर जिसके कॉन्सेप्ट क्या लगने वाले हैं। ओके, आएंगे क्योंकि अभी तुम देख रहे हो कि वर्क पर एनर्जी के कॉन्सेप्ट ही लग रहे हैं वर्टिकल मोशन में, तो अब तुम वर्क पर एनर्जी पे जाओगे तो क्वेश्चन हो जाएंगे। समर्पिता, बोलो। हाँ, फिर छोड़ देने का, 3 बार करने का छोड़ देने का। एक क्वेश्चन 3 बार करने के बाद में नहीं हुआ, उस क्वेश्चन को साइड में रख दो, अगले पे चले जाओ। सोचो सोचो, अगर ये प्रैक्टिस हम अभी नहीं करें, अगर ये प्रैक्टिस हम अभी नहीं कर रहे होते तो तुम्हें इस अपनी इस वीकनेस का भी पता नहीं होता। मतलब तुम जस्ट सोचो कि हाँ, तुम्हें चमका बेसिकली कि हाँ, टाइम प्रेशर नहीं होता तो दिमाग बहुत इजीली सोचता है सही डायरेक्शन में। तो मैं एक्जेक्टली वही बोलता हूँ कि दैट इज वन ऑफ द बिगेस्ट बेनिफिट ऑफ बीइंग ऑन अ प्लेटफॉर्म लाइक वेदांतु, क्योंकि अगर आप ऑफलाइन प्रिपेयर करते हो तो आप कभी भी टाइम बाउंड क्वेश्चंस नहीं सॉल्व करते। तो ये अपने आप में एक बहुत बड़ी प्रैक्टिस होती है जो आगे जाके तुम लोगों को डिफरेंस समझ में आएगा जब तुम्हारी 12 स्टैंडर्ड कंप्लीट होगी, जब तुम एक्चुअली जेईई के लिए तैयार हो चुके होंगे। तब ये इतना बड़ा बेनिफिट होगा ना, जो कि तुम्हारा सब्जेक्ट नॉलेज और तुम्हारे बराबर किसी और का सब्जेक्ट नॉलेज हो और वो आपका ऑफलाइन प्रिपेयर कर रहा है स्टूडेंट और तुम ऑनलाइन प्रिपेयर कर रहे हो, तुम्हें शेयर कॉन्फिडेंस होगा सिर्फ और सिर्फ बिकॉज़ ऑफ दिस पर्टिकुलर फीचर ऑफ वेदांतु। मैं सिर्फ वेदांतु की तारीफ नहीं कर रहा हूं, मैं जेन्युइनली बोल रहा हूं कि हमारे टाइम पे ये फीचर्स नहीं थे, तो वी एक्चुअली हैड ओनली आवर मॉक टेस्ट जो हमारी क्लासेस में होते थे, वही टाइम होता था जब हम एक्चुअली टेस्ट करते थे अपने आप को इन अ टाइम बाउंड प्रेशर। तो ये ऑब्वियसली समथिंग रिलेटेड टू न्यूरोलॉजिकल बायोलॉजी है, जिसमें हमारा दिमाग जब ज्यादा प्रेशर में होता है तो हमारा दिमाग ज्यादा फास्ट सोचता है, ज्यादा जल्दी डिसीजन मेकिंग करता है। कोई बात नहीं, अभी गलत होना इज फाइन, लेकिन स्पीड की चीजें ऑर्गेनिकली हमारे अंदर आना, स्पीड बहुत जरूरी है। दैट इज ओके, गलत होना इज फाइन, दैट इज गुड। फ्लू पे आंसर कोई फायदा भी तो नहीं है, लॉन्ग टर्म में फायदा भी तो नहीं है। मेरा ऑब्जेक्टिव लीडर बोर्ड पे आना थोड़ी है, मेरा ऑब्जेक्टिव है क्रैक करना। दैट्स इट, या ओके, चलो गुड नाइट सर। बट तो हैज मच क्वेश्चंस यार, विशेष मैं यार ये वाले टॉपिक में मैं 50 बार बता चुका हूं, अब मैं रिपीट नहीं करूंगा ये चीज। एक लास्ट डाउट मुझे अभी हेलिडे रेसनिंग करनी चाहिए सॉल्व, मेरे पास इंटरनेशनल एडिशन है। अरे भाई, कितने घंटे मिलते हैं दिन में? आपको तो 24 घंटे मिलते हैं, तुम्हें कितने मिलते हैं? भाई टाइम में तो सब सॉल्व करो ना, फिर कोई नहीं रोक रहा है तुम्हें, जितने कर सकते हो करो। पर ये नहीं होना चाहिए कि तुम सॉल्व करते हो, एक बार ट्राई करते हो फिर सोल्यूशन देख लेते हो। अगर वो अप्रोच है तो फिर किसी फायदे की नहीं है। ठीक है, बस बढ़िया, एज लॉन्ग एज यू हैव टाइम डू इट। ओके, ओके, थैंक यू। सर आपका कोई लाइव लेक्चर यूट्यूब पे किस चीज पे वंश, ऑन व्हाट? ओके, गुड नाइट गुड नाइट गुड नाइट। सर डिड यू सी कम्युनिटी पोस्ट ऑफ वेदांतु जी? नहीं ना यार, अभी कहाँ से कम्युनिटी पोस्ट देखें हम। सर यूट्यूब पे लेक्चर लेते हो आप? आई डिडंट नो दैट कि मैं यूट्यूब पे लेक्चर लेता हूँ। सर दे हैव पोस्टेड 11 12 का शेड्यूल इन, सर दे हैव पोस्टेड 11 शेड्यूल इन 12। अरे ठीक है ना यार, तुम टेलीग्राम पे हो ना विशेष? बाय 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 समझ, ठीक है। चलो गाइस, टाइम टू रैप अप यार, नाउ इट्स वेरी क्लोज टू 11 o'clock। अब बंद करते हैं, ठीक है, फिर मिलते हैं वेडनेसडे को। ओके, चलो देन, बाय बाय, गुड नाइट, बाय गाइस, साइनिंग ऑफ।